Hello, data enthusiast. Welcome to today's exploration into the captivating world of data analysis. Join me as we unravel the secrets hidden within the datasets and discover the power of turning raw information into meaningful insights. Let's dive in. At its core, data analysis is the process of inspecting, cleaning, transforming, and modeling data to uncover useful information, draw conclusion, and support decision making. It is about making sense of the numbers and patterns that shape our world. Data analysis comes in various formats. At first, you can see the descriptive analysis. So, descriptive analysis summarizes and presents raw data to reveal key traits. This fundamental phase shows the data's main trends, distributions, and properties. Descriptive analysis helps analysts comprehend the dataset's structure and find trends using graphical representations, measurements of central tendency like mean or median, and measures the dispersion like standard deviation. After that, you can see diagnostic analysis that explores the why behind observable patterns or difficulties revealed during descriptive analysis. This phase seeks to explain data trends and abnormalities. Diagnostic analysis uses statistical approaches to identify variable correlations, helping explain observed occurrences. It goes beyond describing facts to analyzing the causes of results, making it essential for informed decision making. After that, you can see predictive analysis, which uses historical data and statistical algorithms to predict future trends or results. Based on past data trends, analysts can forecast future events using predictive models. Based on descriptive and diagnostic analysis, this phase helps predict trends, make proactive decisions, and plan for future. And finally, we can see the prescriptive analysis that helps optimize results by providing recommendations for actions beyond forecasting future outcomes. It suggests the optimal option using complex analytics, optimization algorithms, and decision making models. Decision makers benefits from this phase because it predicts outcome and suggests method to accomplish them. Prescriptive analysis is the apex of analytical work, turning data driven insights into practical plans and helping firms achieving their goals. And definitely, this prescriptive analysis completely depends on the proper execution of complete data analysis flow. Our journey begins with data collection. Whether it's from surveys, sensors, or databases, gathering relevant and accurate data is the foundation of any data analysis project. In conclusion, data analysis is not just about numbers, it's about empowering decisions. Whether it is in business, healthcare, or research, the insights gained from data analysis pave the way for informed and strategic actions. Hello, data enthusiast. Today we are embarking on a journey through the complete data analysis workflow. From cleaning raw data to hypothesis testing, join me as we unveil the steps to transform information into actionable insights. Let's dive into it. Our journey begins with data cleaning. This essential step involves identifying and handling missing data, addressing outliers, and ensuring that data is free from errors. Clean data sets the stage for reliable analysis. Once our data is clean, we move on to the data manipulation. This phase involves transforming and restructuring the data to make it suitable for analysis. Techniques like merging datasets, creating new variables, and handling categorical data are common in this phase. With our data prepared, we enter into the exciting phase of exploratory data analysis. Here we use visualizations and statistical summaries to uncover patterns, relationships, and trends within data, gaining a deeper understanding of its characteristics. And then comes data transformation, which actually deals with the distribution of the numeric data. Understanding the distribution of our data is crucial. These steps involves exploring the spread and shape of data points, assessing whether they follow a normal distribution or exhibit skewness. Dealing with distribution prepares us for more advanced statistical analysis. Then comes statistical data analysis. Now armed with insights from EDA and distribution analysis, we delve into statistical data analysis. These steps involves applying statistical methods to draw inferences, make comparisons, and identify relationships within the data. The pinnacle of our workflow is the final sector, which is hypothesis testing. Here we formulate hypotheses about our data, conduct statistical tests, and evaluate whether the evidence supports or contradicts our initial assumptions. Hypothesis testing adds a layer of rigor to our analysis. The complete data analysis workflow takes us from cleaning and manipulation to exploratory data analysis, dealing with distribution, statistical analysis, and finally, the hypothesis testing. Each step builds upon the other, empowering us to extract meaningful insights from raw data. That's all for now. Let's dive into the practical session of the complete data analysis bootcamp. Yes, follow the course instructions and complete all the lessons with practice, and I guarantee you are going to be a perfect data analyst within 30 days. Best of luck and thank you. Hello everyone, welcome to the course. Having a data in front of you, what do you think? What you need to do? Okay, it's simple. Basically, when you get a data, you have to make the data clean. That means you are not capable of doing any analysis, building any machine learning objects with any inconsistent data set. So that is why you have to clean the data first. So at first, we have to load our data set in our Jupyter Notebook environment. So go to ChatGPT and we'll command ChatGPT to provide us the required code. So as you can see that I have written, give me a Python code to load an Excel data. Now hit enter. You can see that how fast ChatGPT provides you the required Python code. So let's understand our code because it is very important to understand your code. Without understanding the code, you will not be able to a perfect data scientist, right? Okay. So at first you can see that ChatGPT provides us this command where it is written that pip install pandas. So pip is a command and install is another command used to install any library that is necessary to perform any particular task with Python programming. So pandas is a library or a package that is necessary to perform any task for any data frame object. So as we are going to load a data set in Excel format, which is basically a data frame format, so we need the library pandas to modify it, to make any analysis, any adjustment or anything in Python. So if you are a beginner and if your Jupyter notebook has no installation of pandas, you have to copy the code, go to Jupyter notebook, paste it here, and now you have to press the shift key and hit the enter. So you can see that the pandas package is installed. Let's see the next lines of code. So you have finished installing the pandas library, right? So you have to import the pandas package or the pandas library in your Jupyter notebook. You can see this line of code where it is written that import pandas as PD. So it is commanding the Jupyter notebook that import the pandas library you just installed as PD. As means alias PD. So that means whenever you write the PD in your code, it refers to any task done from the pandas library. So as we are dealing with the data frame, so whenever you can see any code written with the alias PD, that means for this particular data frame, we are working any task that comes from the pandas library, right? Yes. After that, you can see that the line of code given by ChatGPT, and here we can see that it begins with the excel underscore file and then an equal sign, right? So excel underscore file is our variable, and the equal to means that something is loaded in our variable name. So what is loaded in our variable name? So here you can see that your underscore excel underscore file dot xlsx. So you can see that it is written replace your underscore excel underscore file dot xlsx with the path to your excel file. That means it is telling us to replace this thing with the path where we have stored our practice data. So if we go to here, you can see that our practice data is sales data dot xlsx, and it is stored in a this path. We access this path from the document section to courses to Python plus ChatGPT to data science and then the resources section. So however, we do not need to mention the path because in the folder resources we have opened our ipynb file. So that is why if we just name this sales data.xlsx, then it will work smoothly. After that, you can see another line of code df underscore pd dot read excel and the excel underscore file within the bracket, right? So here df is the variable, and this particular function or the particular line of code is loaded into the df variable. So let's see what is loaded. You can see that the pd dot, that means here we are working to load the data, our excel file in the Jupyter notebook, and to load the data we are using the read dot underscore excel function, and this function comes from the pandas library. That is why to call the function to load our excel file, we have to use the alias pd to mention that the read underscore excel function is comes from the pandas library, and then within the bracket we have input the excel underscore file variable, which is this variable within which we have loaded the name or the path of our excel data. And after that it used the print function to show the first 5 rows of our data frame stored in the df variable. The dot head is a function which is used to show the first 5 rows of our data frame. So just copy the code, go to Jupyter notebook, paste it here, and we have to replace our dataset name, which was sales data.xlsx. If we go to here, you can see that sales data.xlsx, and now we do not need to use the function print because it works automatically with the dot head method. So just press the shift key and hit enter. Here you can see that our dataset is loaded in our Jupyter notebook. So this is all to load the dataset. In the next video, you will see how to deal with missing values in the dataset. Thank you. Hello everyone. Now you are going to see how to deal with missing values in a data frame with Python and ChatGPT so faster, so easily. We have loaded our dataset, and now we have to find out whether there is any missing values in the variables of this dataset. So we have to at first identify which particular variables in our dataset have any missing values. So basically we will go to ChatGPT and give the command that, so here you can see that I write give me a Python code to find out missing values in a data, and here you can see the lines of code. So at first you can see in the code it imports the pandas library again. We do not need to import any library again and again. We just need to import it once, and as we have imported while loading our dataset, we do not need to import it again. So it is showing us to import the dataset as well. We have already imported our data. We do not need this line of code as well, but we need this code. Here you can see that the comment check for missing values in the entire data frame. So this particular line of code helps us to find out any missing values in our data frame and its variables. So as you can see that the code starts with the missing underscore values, which is a variable within which the missing values from the data frame is stored. That means whenever we call these particular variables, it will show us the missing values in each variable in a data frame. So you remember that our data frame was loaded in a variable name df, and at first the df is used, then the dot is null is a method, is a Python method which is used to find out any missing values in the variables of a data frame. And after that the dot sum is another Python method which aggregates all the missing values in each variable in a data frame. And after that you can see the print missing values and any missing values that is higher than 0 to filter out only the variables that has missing values. To filter out, you can see that it use the variable name missing values, and then again within the third bracket it again use the variable names and command to show any variable with missing values greater than 0. However, we'll learn more about sorting and filtering in upcoming lesson. So as we do not need these two lines of code, we'll just copy from here to here. Then we'll go to Jupyter Notebook and paste it here and run the code. So here you can see that the output is showing us two variables. One is order underscore value underscore euro with the number of missing value is 5. That means there are 5 missing values in this particular variable, and similar for another variable which is device underscore type, and it also includes 5 missing variables. Now we have to deal with the missing values with this variable. So we'll go to ChatGPT and tell ChatGPT. So I write that give me a Python code for simple imputer to impute missing values in a variable of a data. So simple imputer is a machine learning function which is used to impute the missing values or to replace the missing values in a variable in a data by a standard measure. So here the standard measure means it can be mean, median or mode. So for any numeric data, we use the either mean value or the median value. But we always recommend to use the median value, as the median value is not affected by the outliers in your data, while there may be a chance to have any outlier in your numeric data, right? But for any categorical variable or nominal variable, you have to use the strategy or the standard measure mode, which is the most frequent value, categorical value in this particular categorical data. However, just run the code. So here you can see the line of code. At first, it imported the Pandas library, but it also imported the simple imputer function. And as you can see, the simple imputer function is imported from the library of Python sklearn.impute. Sklearn is a scikit-learn, which is the library that includes the function of Python applied to the machine learning job or data science job. In this particular section, the simple imputer is a function that is used to impute or replace the missing values in a large dataset as fast as possible by the standard measures like mean, median or mode. In the second line of code, you can see that it loaded the data. We have already done it. We do not need it again. And in the third line, you can see that it defines the column. Here the column name is the variable name. As you can see that the variables are order, value, euro and device type. We'll replace the column name with our variable that has the missing value. In the next line of code, you can see that it starts with imputer. So this is the variable within which the functionality of simple imputer will be stored. So here you can see the in the right side of the equal sign, the simple imputer, which is the function, and it is called with defining its strategy is mean. So what does mean by defining strategy by writing strategy and equal sign? As I told you that for any numeric data, we can replace the missing values by mean or median. So here ChatGPT by default providing us the strategy mean to replace any missing values in our numeric data by the mean value of this particular data, but we will revise it by writing median instead of mean. And in the final line of code you can see that it starts with df and the target underscore column within third bracket. That means the target column, you can see this variable that stored the variable with missing values will define against the column underscore name. Here in this part of code, it is actually showing us that to replace the particular variable such as order value euro by the imputed variable with no missing values of the existing order value euro variable that has missing values. So this particular part of the code is actually replacing our existing order value euro with any missing values by the order value euro variable that is imputed, that which missing values are replaced by the standard measure. And in the right side of the equal sign, you can see the line of code is used to impute the missing values from our target column. Here is the imputer variable that loaded the simple imputer functionality with the strategy mean, and then it calls the dot fit transform. So fit underscore transform is a function. It is transforming our target column's values by implementing the functionality of simple imputer and transforming it to remove the missing values by replacing those missing values with the standard measure. And within the bracket of the fit underscore transform, we can see that our target column is filtered out. That means, so you can see that we have written down df, right, which is our data frame, and we have used the two continuous third brackets. So when you have to import the values of any variable in a two-dimensional array or in a data frame object type, then you have to use two continuous third bracket. But if you only use the one third bracket, then the values of the variable will be imported in front of you as one dimensional array type or in a list type. But you have to import the values of our target column, ensuring it is two-dimensional array or in a data frame format. Otherwise the function will not work properly. So before doing it, you have to ensure that the scikit-learn library is installed in your Jupyter notebook. To do so, you have to use the same line of code you use to install the Pandas library. Just you have to replace the name with scikit-learn. And if you run the code, you can see that the installation is done. And now you have to import the simple imputer from the library by this line of code we talked about, and just run the code. You can see it takes some time but runs properly. Then we have to copy the three line of code to impute the missing values, and just copy here. We have to revise the column underscore name definitely by the numeric value order value euro, and we have to revise it median from mean, as we are using the strategy median to replace the missing values in order euro variable. Now run the code. You can see the code runs very fast. And now let's check this particular line of code to see the number of missing values, which is df.isnull.sum. Just run the code. You can see that the variable order value euro has no missing value right now. That means our 5 missing values are imputed by the median value of the variable. But we have another variable with missing values, which is device type. So device type is a categorical variable. So if we call df dot device type, you can see the values are nominal like mobile, PC, etc. So this is a categorical variable, so we have to use the same line of code, but now we have to use the strategy most frequent, as you can see here. So just copy the lines of code, paste it into another cell, and now you have to at first revise the variable name order value euro by the device type, and you have to use the most frequent strategy instead of median, because the device type is a categorical variable. And now everything is okay. Just run the code. You can see the code runs perfectly. Again, run this line of code to check the overall missing values in our data, and there is a boom. You can see there is no missing values in our data right now. So this is how you can deal with missing values professionally, faster and easily with the help of Python and ChatGPT. That's all. Thank you. Hello everyone, welcome to the new lesson where we are going to deal with the data types of the variable in a data. So dealing with data type is important. Without assigning the correct data type, you cannot make the proper analysis you want to do. For example, here you can see the variable cost, right? So if we proceed to our data, you can see the cost includes values like this one with decimal points. By this, you can ensure yourself that the variable must be numeric data. And in Python, there are two types of numeric data like float and integer. And integer is a numeric data without any decimal point or whole numbers data, and float type data or value in a numeric variable indicate any numeric values with decimal points. So in our case, the cost variable must be float type data. So we have to find out what is the data type assigned by the Python, or whether there is any inconsistent value that make the wrong assignment of the data type by default. So we have to find out and we have to assign the correct one. So at first we have to find out the assigned data type for each variable. So we'll go to ChatGPT and tell ChatGPT, give me a Python code to find the data types of the variables in a data. So just run the command for ChatGPT, and here you can see that at first it import the pandas library. We have already done it. Then it created an example data frame to provide us the complete idea, but we have already our data set. So we just need this small line of code to find out the data type of the variables in our data. So here you can see the data underscore types, which is a variable within which the data types of the data frame is stored. So if you check this small code, which is started with df, and the df is a variable within which we loaded our data, and after the dot dtypes method is used, which is a method in a Python code or the Python programming, to find out the data types of all the variables within this data frame. So if we just copy this small code and go to our Jupyter notebook, paste it here and run the code, you can see variable list and the particular data type for this variable assigned by default. However, you can see the variable country, which is a categorical variable because it includes the names of countries, and definitely it should be an object type data frame, and it is, so there is no issue. Order value euro is a float type. That means it is a values of numeric data with decimal points, so it must be a float type and it is okay. But the cost variable, here you can see the assigned data type is object. Of course not, it cannot be, because the cost variable is an numeric data which has the values of numeric with decimal point. So it must be a float type data, not a integer data or any object data. So here the wrong data type is assigned for this particular variable and we have to fix it. Similar for date time, because the date includes the year, month, day, etc. And here is a particular data type in Python which is date time 64 assigned for the date variables, but you can see the assigned data type is object, so we have to revise it as well. And for other variables, all the variables are categorical variables, so the assigned data type is right, perfect. So we just need to deal with the cost and date. However, in the cost, if we proceed to our data, you can see all the values are numeric. Then why it is showing us the data type is object type data type, which is the data type for categorical variable? Definitely there is an inconsistent value within this variable, so we have to find out the value. And as it is showing us that the data type is object, which is a data type of categorical variable, so there must be a categorical value, non-numeric value or nominal value within the values of the cost. So we have to find out that culprit and we have to remove it to convert the data type to assign the correct data type for our variable cost. So let's ask ChatGPT to provide a required Python code to find out the culprit. So here you can see I write, give me a Python code to find out the non-numeric value from the numeric values in a variable. Just run the command for ChatGPT. So here you can see the lines of code required to find out the culprit. So at first you can see that ChatGPT generated a example sample variable containing the mixed data like numeric and non-numeric as well. Then it created an empty list. However, all the list in Python is made up of the third bracket. For example, you can say this is also a list of the mixed of numeric and non-numeric data, and the list comprised of the third brackets. So as here is no value within this particular third brackets, so we can say this is empty list, and the empty list is stored in a variable called non underscore numeric underscore values. Then proceed to the main blocks of code, and here you can see that from the mixed data the Python is taking each value and iterating through each value by specifying the for before the code. So it is a for loop. That means it is iterating over every value in this particular variable. So after that, here it provides a condition to find out whether the value it has is numeric or non-numeric. For example, you can see a function called isInstance. So this function is used to see whether the value taken have any string characteristics, and it provides condition that the value is string and the value is not numeric. That means you can see that the not is defined and then the value, and with the value dot numeric method of function is used, which is a method of Python to determine whether a particular value is numeric or non-numeric. For example, if we put 78 instead of value, it will show us true because the 70 is a numeric value. But if we put the def here, it will provide us the false because def is not numeric data. So the condition is if a particular value has the characteristics of string and the value cannot be a numeric, then definitely the value is a string value or object type data or non-numeric data in our list, and then those particular values will be added to our empty list. Here you can see the empty list name, non underscore numeric underscore values, with the Python method append, which is used to add any value within a list. So here you can see a value is taken, then the value is tested whether it is string and it is not numeric data, then the value is appended or added into our empty list. Suppose if we take the 42, here we put the 42, and for the 42 value we have tested the value whether it has any string instance and the value is not numeric. You can see the 42 has no string instant or no object type characteristics and the value is numeric. Then we will ignore this particular operation. But if we take the ABC, here you can see the value has the string or object type characteristics and it is not the numeric data. So this ABC will be added to our empty list through this append method of Python. And then you can see the heading is printed and the non-numeric values will be found out. So just copy the code, go to Jupyter Notebook, paste it here. We have to make a revision because we have our data, so have to call the variable df cost. So I told you that df and within the third bracket and quotation mark, the variable name indicate we are bringing all the values of a particular variable from a data frame. So our data frame is df, and in this data frame we have a variable cost. So we are bringing all the values in this particular variable from the data frame. So everything is okay. Just run the code. Boom, you can see the non-numeric values is found, which is triple x. So this is a particular value, the non-numeric value in our variable for which we are seeing the wrong data type assigned. So we have to remove this value from our cost variable, then we have to convert it into float type data. So let's see how we can remove this particular value from our numeric value. So I write that give me a Python code to remove a row including this value of triple x from a numeric variable in a dataset. So run the command. So here is the code. You can see that at first it imported the Pandas library and created the example data. We do not need it because we have our dataset and imported the Pandas library. So it assigns the example variable, the numeric variable, in a variable numeric underscore column, and then it assigns the inconsistent value within the variable in a variable named value to remove. Then our line of code through which we are removing the line that includes the inconsistent value. So here you can see it starts with mask, which is the value in which our variable will be stored without the inconsistent values. So at first it starts with df, so which is our data frame, then the column, numeric column in which our variable is stored. So basically in this particular sense it is extracting the values of each variable from the data frame. Then it puts a condition of dual equal sign. That means from the values of this numeric column we will just have the row that contains our inconsistent value. Here you can see equals to value underscore to underscore remove. That means that we extract all the values, and by the dual equal sign it is filtering only the line of rows from the entire data that only includes the inconsistent value of the variable we defined within the third bracket of our data frame. And after that, we are filtering our data frame again, get the right data without the inconsistent value in the variable of cost. And to do so, we at first define the df, and within the third bracket we put the mask, and most importantly, before mask we assign a tilde sign. A tilde sign is a sign used in Python to accept all the values instead of that any particular value. For example, we are taking all the values, all the variables that are in the data frame except the values which is equal to our inconsistent value we defined with this line of code. And the tilde sign is taking all the values instead of our row including the inconsistent value. However, we can make it more simple by directly assigning the column name instead of numeric underscore column, and assigning our inconsistent value instead of value underscore to underscore remove. And we just need to copy the code, go to Jupyter notebook, paste it here, and we have to make the revisions like at first the variable is cost and our value is triple x, right? So everything is okay. Just run the code. You can see the code runs perfectly. Now if we run this particular codes again, you can see we got an empty list. That means there is no non-numeric value in the variable cost. And now we have to assign the correct data type for the variable cost. So we'll go to ChatGPT and tell ChatGPT, so here you can see the lines of code. We'll ignore these codes again. Have this line of code to assign the correct data type. So you can see that the numeric underscore column, that means we have to assign the variable we are dealing with within here. And in this sense, it again takes the corrected values of the variable we are assigning from our data frame and replace the values of the variable in our existing data frame. However, the most important part is here you can see that we are calling the variables values through this piece of code as we talked earlier, and then the .type method is used, which is the Python method used to assign the proper data type, and within the bracket it puts the int, but we know that our data type is float, so we'll use here float, not int. So just copy the codes, go to Jupyter notebook, paste it here, and we have to just make some revisions again. We have to define our variable name again. We have to define our variable name and we have to revise it to float because our correct data type for cost is float. And now if we check the data type, you can see that the data type for cost variable becomes float 64. So this is how you can completely and professionally deal with data types. However, there are another variable called date, and we have to assign the proper data type for this. So it is simple. We just need to copy this line of code to assign the correct data type for our date variable. We just need to replace the cost with date, and we have to replace the float with date time 64, and you have to put the date time 64 within a quotation mark and just run the code. You can see the code runs perfectly. Again, let's check the data types in the variable of our data set. So you can see that the data type of date variable is converted into datetime 64, right? So let's see our data frame again. And here you can see that the values in the date column is perfectly organized, and at first you can see the year 2020, then the month 12, and then the day 02. So this is how you can deal with data types. Yes, it is very important to check for inconsistent value before dealing with data types of numeric data. So remember it and achieve your destination. Thank you. Hello everyone. So now we are going to deal with the duplicates values in our data set. So it is the most easiest part in cleaning up data set through Python and ChatGPT. There is just we need to perform a line of command and then everything is okay. So just go to ChatGPT, tell ChatGPT that give me a Python code to deal with duplicates. Now hit enter. So here you can see at first it created the sample data. We do not need it, but we need this line of code. Here you can see that the code starts with the variable name duplicates, and in the right side of the equal sign, you can see the functionality of the duplicated function. At first our data frame is called and the third bracket is open, and within the third bracket you can see both side df dot duplicated is mentioned. So dot duplicated is a function of Python which is used to derive the duplicated data from a data frame. So in our case, at first we are applying the duplicated function in our data frame to find out the duplicated rows, and the duplicated rows is filtered from our entire data, and the rows are stored in the variable called duplicates. And then you can see the heading is printed duplicate rows, and the duplicates variable is printed to see the rows which are duplicated in our data. And then you can see the code to remove the duplicate values. You can see that our data frame is mentioned here, then the dot drop underscore duplicate method is used, which is a function to remove the duplicate data from the data frame. And then you can see the heading for data frame without duplicates is printed through the print function, and df underscore no underscore duplicate variables is printed out, which is a variable you can see here within which our data frame where we applied the Python method drop underscore duplicates to remove the duplicated value and store our data frame without the duplicated value in this particular variable. So this variable is called here to see our data without duplicates. So at first we want to check whether there is any duplicate rows in our data frame. So just need to copy this line of code to find out the duplicated rows. So paste it here and just run the code. So you can see here is our output, but we want the output in a fresh way, so we'll remove the print command from the duplicates variable and just run the code. So here you can see the duplicated rows. Here we can see the rows number 15 which is duplicated, and we want to remove this duplicated row from our data. Here you can see the next lines of code to remove the duplicated data, and we just need to run the code. Again we will remove the print function to make our output more attractive, and you can see that this is our data without any duplicated data. So that's all to deal with duplicate value. It is very easy, and here you finished cleaning your data. So your data is now clean. So here you can name it that clean underscore data and put a equal sign within which we'll transform our last data frame without any missing values, without any inconsistent value, without any wrong data types, and finally without any duplicates. And just run the code and call the data and its first 5 rows through the head method. So here you can see our cleaned data. So that's all cleaning data set. Thank you. Hello everyone, welcome to the new lesson of data manipulation. So you have completed the lessons in data cleaning part, and now you are going to start the data manipulation part. So in data manipulation, you will work with your data in some different way to make it easier for further analysis. For example, you may need to sort your data, you may need to filter your data as per some condition, or you may need to add some more variables or add some more data in your existing data. So these are some example work that is necessary to do in everyday data science work life. However, in this particular video, we are going to see how we can easily sort our data by any numerical values and can get some beautiful basic insights from the sorting of the dataset. And yes, you can easily sort such data with the help of ChatGPT by generating simple Python code faster and easier way. So go to ChatGPT. So here you can see that I write, give me a Python code to sort a data set ascending by a numeric value. So you can sort your data set based on any numeric value either in ascending or descending format. Ascending refers to the format of sorting any data set from lower to higher order, and descending refers to sorting any dataset from higher to lower order. So we are going to sort our dataset by a numeric value in ascending or lower to higher order. Run the command. So here you can see the code. Definitely ChatGPT created a sample data by importing the Pandas library, and we do not need this because we have done this task. We just now need this particular line of code to sort any dataset by any numeric values in ascending or descending format as per your want. As you can see, the code started with df underscore sorted, which is our variable name within which the sorted data frame by any numeric value in ascending format is stored. In the right side of the equal sign, you can see the code start with the df, which is the variable containing our data set, and within which we can see that dot sort underscore values function is used to sort the data frames values. As you can see, within the brackets of sort underscore values is by, which includes the numeric value. In this particular case, the numeric value is age, and by these numeric values we are going to sort our data frame in ascending format. And we can see that the ascending and it's equal to true. If we put false instead of true, then it would be sorted in a descending format. So as we put true here, so it will be sorted in ascending format. That's all. You just need to copy the code, go to Jupyter Notebook and paste it here. Now we have to make some revisions as per our want. So we want to see the cost in ascending format. We can see the lowest cost at first and the highest cost at last. So we just so we just need we just need to change the age into cost, and everything is fine. Just we can run our code. Now, if you call this particular variable within which we have loaded our sorted data, you can see that the costs values are in lower to higher order. You can see the first row include the lowest cost and the last row include the highest cost value. And you can see that the lowest cost belong to the games category product type, and the highest cost belong to others product category, and the second most highest cost belong to the books category products. So this is how you can easily find out some comparison between any category, any nominal data as per some numeric data by sorting your dataset in ascending or descending format. That's all. Thank you. Hello everyone. In this particular lesson, we are going to see how we can filter out any large dataset based on some condition. And there are several conditions which you can follow to filter out your dataset as per your want or need. However, you can see that we have a sales data and we can see some order values, some cost, category, etc. sales information for various countries here, such as Sweden, France, Netherlands, etc. So suppose you want to see only the information such as order value, euro, cost, date, category, customer name, sales manager, sales representatives, only for the country France. Then you have to filter out the data set to get the information that only comes from the country France. So let's see how we can filter out this entire data for the country France easily with the help of ChatGPT. So go to ChatGPT and write, give me a Python code to filter dataset for the country France. That's all you need, just run the command. So you can see that ChatGPT again created a sample data to make you understand very easily how the code works and why the code is necessary. However, we do not need it. We just need this tiny line of code, the tiny line of Python code to filter out our entire data frame for the country France. So as you can see that the variable name within which the filtered data set is loaded is filtered underscore df, and in the right side of the equation sign you can see that the code for filtration, and we'll start understanding the code within the middle of this line of the code. So at first you can see in the middle of the code the df and the third brackets open and within which the variable name country within the quotation mark. So you know the format. Through this format you have brought out the values of the variable countries in a list format, right, in 1D array. And within this list you are selecting only the values that is highly matched with the name France. And in Python, by the double equal sign, it indicates you have to find the information that completely match with the information or with the condition you set, like we set the condition here for France. When the list is checked for the particular value France, we will get some results like true or false. That means when the list will see that some values in this list will match with the value France, it will provide us the result true. And for those values within with which the value France is not matched or doesn't match, we will see the output false. That is why these particular conditions will be again filtered out with the third bracket, and before this we are filtering the entire data. So we provide the, you just need to copy the code, go to Jupyter notebook and paste it here. We will change the variable name to France underscore df, and we can see that the name of our variable country and the first letter is small letter, so we have to ensure the first C letter is smaller c. Then everything is okay. Again we have to ensure that the spelling and everything for the value France is equal to the value France given within the variable. And now we just need to run the code. You can see the code runs perfectly. Now if we check the variable France_df, you will see only the information for the country France. In the next filtering process, you will see a mixture of filtration with two conditions. For example, you have filtered out your data based on the country France. Now you want to filter out your data both for France and for the games product category. That means you want to see the output data that only contains information both for France and for the product category that includes games. So let's see how we can do so with the help of ChatGPT. So write that give me a Python code to filter dataset for both the country France and for the product category games. Now run the command. So here you can see the code. We do not need these codes. You already get it. We just need this long line of code. Don't worry, this is not much long either. So you can see the variable name filtered_df that contain the filtered dataset we provide per our condition. You can see there are two parts of the condition which is separated by the condition sign and. This and sign separated our condition but also works to integrate both conditions work together. For example, in the left side of the sign and you can see data frame is filtered out for the country that equals to France. And in the right side of the sign and you can see that the data frame is filtered out for the product category games. So the same things you have done twice, one for the France and another for the games, and you have separated the conditions with the first bracket, but between them you provide the and sign to ensure that both conditions work perfectly. And then you have encaved the entire conditions within the third bracket to filter out further for your entire data frame to get the result you want. So that's all. Just copy the line of code, go to Jupyter Notebook, paste it here. We'll revise the name again. For this, we'll write France_games_df. We have to revise our variable name country, and we have to revise the category name, which is only category in our dataset, as you can see here. However, everything is okay. Just run the code. So the code runs perfectly and call the variable name. And you can see the dataset filtered out for only the country France and the product category games and nothing else. And at last, you will see how to filter out any data to remove any particular things from your dataset. For example, now we do not want to include any information from France. That means we want to remove all the information for the country France from our actual dataset. Let's see how we can do it. So write, give me a Python code to filter dataset by removing the country France. So here you can see the code. If we look at the line of the code, everything looks similar, right? The values of the variable countries are filtered out at first in a list format. Then you can see the France here, everything looks fine, but there is a change. You can see the change in the operator. Here the operator is not the dual equal signs, rather one exclamation sign and one equal sign. This combination of sign in Python is called not. At first, the Python code filtered out the list of the values of the variable country. Then it is commanding that do not include the results that match completely with the value France. You get the results, and the results are again filtered out with the third bracket and the data frame. We just need to copy the code, go to Jupyter Notebook and paste it here. Revise the name like not underscore France, then country, and everything is okay. Just run the code. Now call the variable, and here you can see that there will be no countries from the country we removed just now, which is France. So this is how you can filter your data very easily and smoothly with the help of ChatGPT and learn how the Python codes for filtration works. That's all. Thank you. Welcome to the new lesson, and in this lesson we are going to see how we can add some more variables, extra variables in our existing data. And you can see that we have our existing data, which is our cleaned underscore data, and we will add another significant variable, which is refund, within this data set. And for this we have to load the data that contains the variable refund. You already know how to load the data. You have the code, you can just copy it, and you can just paste it. And now you have to revise something. At first you have to revise the data that contain the refund variable, which is extra variable dot xlsx. Then you have to change the variable within which you will load your extra variable data. You can name it like extra underscore vars, and you have to make sure that you call the dot head function for the extra underscore vars. Now run the code. You can see the first 5 rows of our data that contains the refund. Now let's see how to get the required Python code from ChatGPT. Here you can see I write give me a Python code to merge one data with another on order ID. Why I write order ID? Because if you see that our extra data includes the order ID, as well as our existing data include the order ID. So order ID is the common variable that is present in the both data, and the data will be merged for only the matching ID that presents in both data. For example, if we check this particular order ID start with 70, you can see that start with 70 and ending with 66, the order ID is present for this data as well. So if the Python see any order ID which is present in our existing data but not present in our extra data or vice versa, those particular data will not be added. Command the ChatGPT. Here you can see the code. So ChatGPT created two sample data set and we do not need it. We just need this small piece of code, and you can see the merged underscore df is the variable within which the merged dataset will be loaded. And in the right side of the equation sign you can see our code. At first it present our first dataset. As per the ChatGPT, the first dataset is df1. Then the dot merge method is used. It is a Python method which is used to merge one dataset with another one. And you can see within the bracket of the merge method, the first value is the second dataset, and then it specifies on which common variable we need to make the merge operation. That's all. Just copy the code, go to Jupyter Notebook and paste it here. Make some changes like our first data is cleaned underscore data, and the second data is extra underscore vars, and everything is okay. Just run the command. Now call the variable merge underscore df. You can see that an additional variable called refund is added perfectly with our existing data set. So this is the simplest way you can merge any data as per your wish. Thank you. Welcome to the new lesson, and in this lesson we are going to see how we can add some more data for similar variables, but the data will be added vertically, not horizontally. That means Now we are not going to add any extra variable. Rather, we are going to some extra data or information by row for the variables present in our merged underscore df. Let's first import the extra data, and yes, you can do so by simply copy the code and paste it here. Just name the data that contain the extra data, which is our extra data.xlsx, and you can change the variable name like extra underscore data on which you will load your extra data and run the code. You can see this is our extra data and the first 5 rows of our extra data including the variable refund. So this data set will be added at the below of our existing merged underscore df data. So this method is called data concatenating. Now we will see how to do it with the help of ChatGPT. So I write that give me a Python code for data concatenation. That's all you need. Just run the command. So here you can see that ChatGPT created 2 sample data to provide you the hints how to do it. However, this is the line of code we need to concate the data set, and you can see the concatenated data will be loaded our concatenated underscore df data variable, and our code starts with the alias pd. You know what does it mean, and yes, the alias pd is the s form of pandas library. That means the dot concate is a function from the pandas library and we are directly calling it from the pandas, and that is why the pd dot concate is written. And within the brackets of concate you can see the both dataset we are adding together, and here the datasets are df1 and df2 as you can see, and for our case the datasets are merged underscore df and extra underscore data. Just copy the code, go to Jupyter Notebook, paste it here, and make some revisions. So at first our data is merged underscore df, and our second data is extra underscore data, and we want to make it final underscore df and run the code. You can see the code runs perfectly, and if you call the final underscore df, you will see that the total number of rows now 1007, which was approximately 997. So additionally we have added approximately 10 extra rows in our existing data, which is called data concatenating. However, this is how you can add some more data for similar variables present in your existing dataset. So here we have finished our data manipulation process. In the next lesson, you are going to see how to do exploratory data analysis to generate some significant insights from our final data frame we have. That's all. Thank you. Here you can see so many questions, and specifically we'll answer these the questions from what is the primary country of residence for majority of our customers to which device is predominantly used for making product purchase. By applying the frequency analysis and answering the questions and getting the significant insights, let's proceed to answering one by one questions by the help of ChatGPT. Before answering any questions for exploratory data analysis, you have to understand what analysis is required to perform the analysis and finding the correct answer. To do so, you have to analyze your question at first to determine which or what type of analytical method is appropriate to find the accurate answer and insight for this particular question. And you can see the first question is asked us to find out the country of residence in which majority of our customers reside in. So in our final data, you can see a variable country, As per our question, if we make a frequency analysis that will provide us the frequency of the countries in our data set, from which we will be able to find the most frequent country, and we can define that particular country as the country in which majority of our customers reside in. Let's see by practically implementing this thing. So to make the frequency analysis, we'll go to ChatGPT and we'll ask ChatGPT, give me a Python code for frequency analysis. Now run the command. So here you can see the code. So at first ChatGPT created the demo dataset with the help of Pandas that we have already loaded in our Jupyter notebook. So this is the line of code we want or we need for making the frequency analysis for any variable. You can see the value underscore frequencies, which is the variable within which the counts or the frequencies for the values of a categorical variable is loaded. However, you already know that frequency analysis is the suitable analysis to define the counts for the values in a categorical variable. As for example, in our case, the country is a categorical variable and we are counting the frequencies of each value or the each country within this variable. However, in the right side of the equation, you can see at first the values of our variable is filtered out within one day array as a list, and on that particular list the dot value counts method is used to count the frequencies of each value within this particular variable. So this is so easy. Just copy the code, go to Jupyter notebook and paste it here. Make some revisions. At first we are making the frequencies of country, right? So that we will change the variable name value to country and everything looks fine. No, because you have to ensure that we are analyzing our data based on the final data frame that we have found by some addition, subtraction, editing, etc. Now everything is okay. You can run the code. You can see the code runs perfectly. If you click on the plus sign, it will provide us an additional cell after the cell you just used. And if you call the variable country underscore frequencies, you will see the list of frequencies of country. And here you can see that most of the customers reside in Portugal and then France, then Sweden and then UK, and only 2 customers we can see comes from Austria. So if I told you what is the answer of this particular question, that what is the primary country of residence for the majority of our customers, you can say that the majority of our customers comes from the 4 countries, which is UK, Sweden, France and Portugal. Now we would like to visualize this particular data in a bar chart. Let's see how we can do so. You can see I write give me a Python code to plot the result of this value count. That means we are using the value counts to make the frequency analysis, right? So we want the result of this value count as a bar chart to plot the results. So now just run the command. ChatGPT will provide you the most suitable visualization. So here you can see the code. At first you can see that an additional library is imported by ChatGPT, which is matplotlib.pyplot, and it is loaded as PLT. That means whenever we will write the PLT in our code, that means the particular function or method will be derived from this particular package matplotlib.pyplot. However, let's first copy and paste this line of code because it must be present before running the code of data visualization. Then you can see the data creation by ChatGPT, which is an example data, and the value counts or frequency analysis code. However, We do not need this. We just need these particular lines of code to visualize our data. So at first you can see the first line of code depicts the plt.figure. So the dot figure is a Python method of visualization derived from the matplotlib library, which is used to define the size of the figure of the plot. So here you can see within the brackets, you can see the fixed size 8,5. So 8 refers to the width of your plot and 5 refers to the height of your plot. Next, you can see the category underscore frequencies, which is the variable you can see here within which we have loaded the result of frequency analysis of a categorical variable, and with which the dot plot Python method is used to plot the result. And you can see within the bracket of dot plot method, the kind is set as bar. The kind is a thing which defines the kind of or the type of visualization you want in the dot plot method, and we defined it as a bar because bar plot is a very suitable plot for visualizing the result of categorical data. Then you can see the color is defined sky blue and the edge color is defined black. However, in the next line of code, you can see started with plt.title. So dot title is a Python visualization method which is used to assign the title of our plot. And then you can see the dot x level and y level. X level is the Python method to assign the name of the x-axis, and y level is the method to assign the name for the y-axis. And then you can see plt.xticks, in which you can see the rotation is equal to 0. Here the rotation is the amount of degree within which you want to show the name of the x-axis levels. If you make it 90, then the x-axis levels will be showed in front of you as a 90-degree vertical way. And finally, the dot show is the Python code to show the plot you are creating. That's all. Just copy the code, go to Jupyter Notebook and paste under this. And now you have to make some revisions. At first, you can see the variable within which we have loaded the frequency analysis of country is country underscore frequencies. So we'll copy it and replace the category underscore frequencies. Then we'll change the title name, which will be set as the primary country of residence for the majority of customers. The category will be revised as our country, and frequency will be frequencies, no problem. And if we run the result, you can see the bars, but you can see that the name of the countries collide with each other. So if we make the rotation is equal to 90 and run the code, you can see that the x-axis levels or the countries levels are vertically assigned, and you can see everything very clearly. From the graph, you can easily understand the most or the majority of the customers reside in Portugal, France, Sweden, and UK. Proceed to the next question, and here you can see that it asked which product category has the highest frequency of sales. Okay, so here you can see a variable name category which includes the name of the product category. So if we find out the frequencies of each category, you can easily select the product category with the highest number of sales, right? No doubt. Yes, so you can just copy the code, paste it here, make some revisions. In our case, we can delete product cat and our variable name is category. Everything is okay. We can copy the variable name and paste below it to see the table and run. Here you can see The highest frequency of sales for the product category belongs to clothing, games, electronic appliance, and so on. However, let's visualize this result again. We just need to copy this code except copying the import function, because we do not need to import these things again and again. We just need to change something, that at first we have to change this with product category underscore frequencies, and we have to change the title as well. So we can change it this way. The title is the product category has the highest frequency of sales, and definitely the X level will be products category, and frequency everything looks fine. Just run the code. Here you can see the category of the product with the highest number of sales. In the next question, you can see it asks to identify the top 5 customers with the most repeat purchases. Okay, so here you can see you have a variable name customer underscore name. If we make a frequency analysis, you will get the frequencies of the repeat buyer who purchase the product most frequently, right? No doubt. We can again just copy the code, paste it here, make some changes. In our case it is customers, and definitely the variable name is customer underscore name. We'll copy the variable name and paste it below here. Just run the code, and here you can see the top 5 customers who make the most repeat purchases are Johns and Sons, Hassel, Swaniwaski, Dickinson, and Murray. In the next question, you can see it asked, who among the sales managers has achieved the highest number of sales? Again, if you go to your data, you can see a variable named sales underscore manager. If you make its frequencies, you will see the manager who made the most frequent purchase happened by the customers. So again, we just need to copy the code, paste it here, make some revisions. In our case, it is salesman, and the variable name we need, the variable name is sales underscore manager. We can just easily replace it, and again we can paste the variable name under the code, and sales manager who achieved the highest number of sales is Celine Tumasian with approximately 242 sales. In the next one, you can see that it asked who are the top 5 sales representatives with the highest number of sales. Again, if you go to your data, you can see the variable sales underscore rep. Let's make a frequency analysis of it to see the sales representative who made the highest number of sales. We just need to copy and paste, make some changes like sales rep, and here the variable name is sales underscore rep, and everything looks okay. Just run them. So you can see the top 5 is here. They are the sales representatives of top 5 made the highest number of sales. And finally, you can see the question asked, which device is predominantly used for making product purchases? Okay, so if we go to your data set, you can see the device type as a variable which depicts the device that a customer used to purchase a particular product. We will again copy the codes and paste it here, make some changes like here you can see the dev tab, and the variable name is device underscore type, and we can see that huge portion of the customers used PC while purchasing a particular product, and the amount is approximately 789. Let's plot this particular result in a pie chart. Okay, here you can see a long command I made, which is give me a Python code to calculate percentage from value count result and plot the percentage in a pie chart, because pie chart is mostly suitable for plotting the percentage results of various categories in a particular categorical variable. Here you can see that ChatGPT created a demo data and make the value counts by importing the relevant libraries. However, we can see here the comment calculate relative frequency or the percentage. These particular lines calculate the percentage of each categories based on its frequency. Here you can see the variable within which the percentage data will be loaded, but after the equation sign you can see that a equation is created, and at first you can see the category underscore frequencies, which is this variable within which the frequencies or the counts of each categorical values is loaded, and the values are divided by, which is defined by this slash sign, and divide by the category underscore frequencies dot sum. That means the total number of values, if you add the frequencies of each category in the categorical variable, you will see the total, which can be found by this particular code. And dot sum is used to calculate the aggregation of the values, and here the values comes from the frequency or the counts for each categories within the variable, and the result of the division is multiplied by 100, and the result is loaded within this particular category underscore percentage variable. And after you can see the dot figure, which assigns the size of the figure, and then the plt.py is used to plot the pie chart. The dot py is the Python method to plot the pie chart. However, within its bracket you can see the category underscore percentage. This is the particular variable within which the percentage are stored, and the labels are defined as the category underscore percentages dot index. That means you need the labels to define the particular pie is belong to. For example, which particular pie is belong to what categorical or what categories in a categorical variable. And here the labels are defined as the indexes of the category underscore percentages variable. Let me show you it practically. For example, here you can see the device type frequencies, and you can see the PC, mobile, tablet and their respective counts. And here the PC, mobile and tablets are the indexes, and these particular counts are the values. For example, if you use the dot index, here you can see the list of indexes or our device types name. So it will be similar for this particular code as well. And finally, you can see the dot title, in which the title of the pie chart is assigned, and plt.axis is equal to define the aspect ratio equal for the pie is drawn as a circle. And finally, the dot show is used to plot the pie chart. However, just copy the code from here to here and paste it this cell, and make some changes, like we want to plot this, so we'll name it dev type underscore percentage, and we'll replace the category underscore frequencies by the dev type underscore frequencies wherever we can see it. And here you have to again change the category underscore percentage by the dev type underscore percentage wherever you can see this, and you have to change the title Definitely. However, I can name this like this way, where I will write that the device is predominantly used for making product purchases. Everything looks fine, just run the code. Here you can see the pie chart. You can see that approximately 78.3% of customers used PC while ordering or purchasing a particular product from your superstores. So this is how you can use the frequency analysis to get some significant insights for your subject matter. In the next video, I'll show you the application of descriptive analysis in numerical variables and again find some more significant results. Thank you. Hello everyone, welcome to the new lesson, and in this lesson we'll continue the exploratory data analysis second phase, in which you will see how to make descriptive analysis for numeric variables. In the previous lessons, you have learned the techniques of frequencies analysis and its implementation on categorical variables to find significant insights. But what about numeric variables, right? Okay, we'll use the mean, median, mode, percentiles, standard deviations, variance, etc. measurements to find out significant insights for numeric variables. So let's see at first how to calculate the descriptives of the order value, cost, and refund, the three important numeric variables in our data set. So here you can see I write, give me a Python code for descriptive analysis for three specific numeric variables in a data frame. So what actually I am going to do? Just run the command. So here you can see ChatGPT again created a sample data, then we do not need it. You can see that this in this particular line of code, it defines a variable and loaded the numeric variables for which it is going to make the descriptive analysis. And in its case, the numeric variables are age, salary, and experiences. And in the second line of code, which is our main code to calculate the descriptive analysis, here you can see that the numeric underscore columns are put within the data frame and third bracket to filter out these specific three numeric variables from the entire data frame it created, as you can see here, and within which it used the dot describe method, which is used to find the descriptive analysis such as mean, median, mode, maximum, minimum, etc. measures for numeric variables. You can just copy these two line of codes, go to Jupyter notebook and paste it here, and you have to make some revisions. At first, our first numeric variables is order value underscore euro. Our second variable is the cost of product sold, and the third variable name is refund. So we have changed them. Now we have to change the data frame we are using. Here we are using the final data frame. Everything looks fine. We have to copy the variable name and paste below it to find the numeric summary table, and you can see here is the boom. So at first you can see that we have information on 1009 instances of purchases, costs, and refunds. Secondly, you can see on average each purchase is about around 113,000 euro. The average cost to the business for each purchase is around 94,000 euro. The average amount refunded to the customers is approximately 49,000 euro. Now comes to the standard deviation. The numbers can vary from these averages by around 61,000 euro for purchases, 51,000 euro for costs, and 28,000 euro for refunds. This shows that there is some fluctuation in the values of the order value, cost and refund respectively. The smallest purchase was about 15,000 euro, as you can see in the minimum sale for the order value euro section. The lowest cost incurred by the business for a purchase was approximately 12,000 euro. The smallest refund given to a customer was 1,009 euro. Now comes to the 25 percentile. 25% of the purchase had values under 65,000 euro. 25% of the cost were under 54,000 euro, and 25% of the refunds were less than 24,000 euro as per our dataset. However, the 50% indicating the median value or the median order value, median cost, and median refund, as per our analysis, we can see that the median order value was around 105,000 euro, and the median cost were around 86,000 euro, and the median refunds were around 48,000 euro. Similar to 25%, we also get the 75 percentiles, and we can see 75% of the purchases or order values were under 151,000 euro, and we can see both the 75% for other tools such as cost and refund, which are around 126,000 euro and 74,000 euro respectively. Finally, come to the maximum value. We can see the largest purchase recorded was around 383,000 euro. The highest cost incurred for a single purchase was approximately 304,000 euro. The largest refund given to a customer was around 99,000 euro. This is how you can get a brief but useful insights for the numeric variables you have as per your subject matters. However, now we are going to see the distribution of these three numeric variables to get some precise insights again. So we'll go to ChatGPT. So here you can say, right, give me a Python code to plot the distribution of three numeric variables in one figure. That means we want to see the distribution in one figure so that we can make some comparison between them. Just run the command. Here you can see the long code for our data visualization. You can see that another Python library is loaded, which is Seaborn, and it is loaded as SNS. It is the Python library for advanced data visualization. This data visualization can be plotted with a little number of codes. Always be careful that whether in your Jupyter notebook the matplotlib.pyplot and Seaborn is installed. If not, then you have to install it by the way I have shown you. However, for now, let's copy this particular library's code to import it, and we'll use this to import the Seaborn in our Jupyter notebook. After that, you can see ChatGPT created the sample data. We do not need it, we can ignore it. And here you can see the lines of code to make the visualization or the histogram we wanted for our three variables in one row and three columns. At first, you can see the dot figure is used to define the sizes of our figure, and you can see the three blocks of code for each particular variable. In our case, we will use each particular blocks of code, one for order value, one for cost, and one for refund. At first, we will use this first block for our variable order value, but it is used for age as per ChatGPT's example. However, let's understand the codes. You can see that plt.subplot, and it is defined as 131 because we are using one row and three columns. Here you can see that ChatGPT defines you. It is indicating one row, three columns, first subplot, and that is why it is written as 131. And in the next, you can see dot hist plot is used from the Seaborn library. That is why the SN is written at first of it. and after within which you can see the variable is filtered out from the data frame, and KD is defined true. KD is the bell curve over the distribution of the histogram. So that is why it makes true, and it is required for some professional analysis. That is why we will remain it true. And after the plt dot title is used to assign the title for this particular plot. Similarly, in the next block of code, it is used the dot subplots and 132. That means for the figure size 1 row and 3 columns, this is our second subplot. And you can see the dot hist plot is used again, and within which the second numeric variable is filtered out from the data frame, and the title is set for this. And similarly, the 133 defines the third subplot of our 1 row and 3 columns figure, and dot hist plot from Seaborn is used for the third numeric variable, and the title is set as well. Finally, the plt dot type layout is used to adjust the spacing between the three graphs, and dot show is used to show the results. However, we will copy. Now we have to make some revisions. At first, we have to revise the final df wherever we can see that df is written, because we are dealing with the final df, and we have to assign our variable names. First one is order underscore value underscore euro. We have to assign the title as order value distribution, and for the second block we'll use our second variable which is cost, and here the title is cost distribution. And for the third block we will use our third variable which is refund, and here it is refund distribution. Now run the code. So here you can see the distribution of our data. Lower this amount, you can see the cost distribution. You can see that most of the cost belong to the lower portion of the data, and the refund and the distribution of refund is approximately similar for all the values. However, now we will check various important descriptive measures through the use of box plot. So go to ChatGPT. So I write, give me a Python code to plot the box plot of three numeric variables in one figure. So here you can see the similar codes again, and you can see that at first it defines our figure size, it defines our number, our subplots, and it is similar for all the blocks of code. Just the difference is in this particular line of code in the three separate blocks of code, and which is the dot box plot. And this dot box plot method is used to plot the box plot for any numeric data, and within these brackets we have just defined the data which is the values of a particular numeric variables only, and the rest are similar as we have described for our previous code of histogram. So just copy the codes, paste it to a new cell, copy the rest, and again you have to revise the df to final underscore df wherever you can see it, and definitely you have to change the variable's name for each block. Here you can see order value, euro, cost, and refund. Definitely you have to change the title. For the second block, we will provide the cost title, and for the third, we will see the refund box plot. So run the code. Here you can see the box plots. Okay, let's understand the box plots now. So here you can see the box plots of cost. The box plots define so many measures of descriptive analysis. You can see a middle line here. This particular middle lines is representing the median values of the data. So median is the value in the middle of the data. If you distribute or arrange the data from lower to higher or higher to lower order, this particular value is not affected by outliers. So it is important to include in the descriptive measures. You can see the median cost is approximately around 80 to 85,000 euro. The upper line of the median cost, you can see it is the 75 percentile. 75 percentile defines that the percentage of the data that is lower than a particular value. You can see the particular line indicating the 125,000 as a cost, and we can say 75% of the refund is below or lower than 125,000 euro. In the lower line or the axis of the box after the median line, you can see here it is the 25 percentile that defines the number of percentage that is lower than a particular value, and the number of data under 25% that is lower than a particular value. Here the particular line indicating nearly 50,000 euro. So we can say 25% of refund is under 50,000 euro. This particular line, which is at the last of this box plot, this particular line at the last, you can see, is indicating the minimum threshold for a cost, for a possible cost, and you can see the minimum threshold is under 50,000 euro, and this particular line indicates the maximum threshold for any possible cost, which is between 200,000 and 250,000 euro. And at the above the line, you can see some points which are indicating as outliers as per the calculation of statistics or statistical calculation, and these particular outliers are considered as a culprit of the normal distribution. However, you will know more about them while dealing with distribution in the data pre-processing part, which is the must requirement before implementing any machine learning or data science model. That's all. Thank you. Hello everyone, welcome to the new lesson. In this lesson, you are going to learn something new with the amalgamation of the categorical variable and the numeric variable. In the couple of last videos, you have learned how to do frequency analysis, which is required to analyze any categorical variable. And you have already known that the way of dealing with numeric value by calculating its average, median, 25 percentile, standard deviation, etc. measures. So you have dealt with the values in a particular variable separately. For example, you used the country variable to calculate the frequencies of each country in this particular data set, and you have found out that Portugal was a country in which the highest number of customers purchased from this superstore. But now, if I pick the first question, here you can see that identify the top three product categories based on both order value and cost. In previous lesson, you have found out the top product categories based on their purchase numbers or the purchase frequencies. How many products are sold in a particular product category. But now you want to see the top three product categories based on their sales value or order value, the amount of that particular product is sold to a couple of customers. Along with, you want to see the top three products that have high cost. So in this particular sense, when you are going to calculate to answer the question, your output will be shown in front of you in a format of 2 or 3 columns. In the first or the left section, you will see the list of product categories and its name. And in the right section, you will see the numeric values or any representative numeric values, which can be the average or mean values or median values or any calculative values like summation or aggregation, etc., which will be defined based on the situation that a product on a particular question asked. To answer such questions, which requires the mixture of categorical and numeric variable, you have to use the method group by. However, let's ask ChatGPT to provide us the code, and then you will get a proper understanding with a practical example. So I write, give me a Python code to calculate median order value for the product categories. Now run the command. So at first you can see that ChatGPT created a sample data and loaded the Pandas library, and we do not require these things. We will require the code from this particular line. So you can see that the median underscore order underscore value, which is a variable within which we will load the result of our question that asks to identify the top three product categories by order value. And to measure the representative amount of order value, we are using the median. That means we will see in our output the product categories respective to their median order value. However, you can see that the code started with the df dot group by, where the df is our data frame, and in our case definitely it will be final underscore data frame or df, and within which the dot group by Python method is used. And as I told you that to calculate such thing you will need the Python method called group by, and within the Python method at first we have defined our categorical variable that includes the name of product categories such as games, books, etc. After that, we have created the list of variable that includes the values of order value. And this particular code actually creates a list of values in the order value, and with which the dot median Python method is used to calculate the median of those values based on each product category. So we just need to copy the code, go to Jupyter Notebook, paste it here, and definitely we have to make some changes. At first we'll change the final underscore df from the df. We have to define the product category variable name is perfectly included within the function of dot group by. So if we proceed to our data set, here you can see the category is the variable name that includes the values of product categories. So we'll change it like this way. And in our dataset the order value is in the variable name order value euro. So everything looks perfect. We just copy this particular variable name and paste under the code to find out our result. So here you can see we got an error, and the error is saying column not found order value euro. So we made a mistake in providing the name of the variable that has the order value, because we put the capital letter V, but the actual spelling is with the smaller letter V. Now if we run the code, you can see the answers. So here we can see that the particular product categories and their respective median order value. So from this, we can identify the top three product category as per the order value. For this, we just need to sort the values from higher to lower order. So we already know how to sort the values from higher to lower order or descending format. We just need to make sure the sort underscore values function, and within which we'll define the ascending is equal to false. So you have learned this particular method of Python in your sorting lesson, right? Exactly. Now, if you run the code, you can see we got a sorted list in which we can see the top three product categories with the highest median values, median order values. And we can see the top three product categories are accessories, outdoors, and smartphones. Now let's check what are the top three product categories based on the cost of goods sold. So we will just need to copy this particular code and paste it to a new cell and make some revisions. At first, we will change the variable name to median underscore cost, and then we'll change the numeric value name because we want to see the median cost per category, and everything will be okay except we have to change the median underscore value by the median underscore cost because now we want to see the median cost except median value. So if we run the code, you can see the top three product categories based on the median cost of goods sold. You can see the highest median cost belong to the product category accessories, then smartphone, then outdoors. So this is how you can use the group by method and find some significant insights of it. In the next lesson, we will talk more about group by method for several business analytical or exploratory data analytical questions. Thank you. Hello everyone, welcome to the new lesson. So you have already know the application about dot group by method. However, let's proceed to our next question in which we can see determine the top three customers who contribute the most to profitability and have the highest expense. You can see in our data set the order value euro is a measurement that a particular customer's order in a particular purchase. So the order value euro is definitely our measure of profitability or revenue. On the other hand, our main cost of the superstore was the cost of goods sold, and that is why the measure of expense will be the variable cost. So if we calculate the median order value and cost for the list of customers we have and arrange them from in a higher and lower order, we can again find out the top three customers who contribute the most to profitability. So we will use the same code again. So we just need to copy the similar code and paste it to an ESLs. We need to make some changes to median underscore customers, and definitely we have to change our categorical variable, and now our categorical variable is our customer variable, which is actually customer underscore name. So we will revise it, and our first variable of profitability is order underscore value underscore u, and everything is okay. Just need to run the code. So here you can see that as per the median order value, our profitable and most profitable customer is this particular customer with a median order value of approximately 200,000. And here you can see the top three most profitable customers, as per our data. And similarly, if you copy the codes again and paste it to a new cell and just change the variable name to cost and make some changes like adding underscore cost to the variable names and keep everything similar and run the code, you will see the most expensive customers as well. And here the most top three most expensive customers list. And you can see the customer on which the superstore spent more expenses was around a median value of 163,000 euro. So this is how you can easily find out your top three customers based on profitability and highest expenses. Proceed to the next question. And here you can see that it asked which sales representatives transactions resulted in the highest amount of refunds to customers. So you know that in our dataset we have added a new variable called refund. So if you calculate the median refund per sales representative and arrange them to higher to lower order, you will see the list of sales representatives whose transactions are resulted in the highest amount of refunds to customers. So definitely we'll use the similar dot group by method and make some revisions to answer such questions. In our case, we can name it sales underscore rep. And we have to change our categorical variable again. And here the categorical variable name sales underscore rep. We are dealing with the variable refund. So we have to change the numeric variable to refund. And everything looks fine. Just run the code. So here you can see the list of sales representative from higher to lower order based on the refund that is made to a particular customers. You can see that the top 3 to top 5 sales representative who made a huge amount of refunds to customers, and the person in the first position made approximately a median refund of 65,000 euro. So this is how you can easily make some interesting analysis by the mixture of categorical and numeric variables as per the question you have for the exploratory data analysis in your everyday life by using the dot group by method. So that's all. Thank you. Hello everyone, welcome to the new lesson. And in this lesson, you are going to deal with the techniques of pivot table by the help of Python and ChatGPT to answer your questions in exploratory data analysis. So at first, let's explore what our question is. So the question asked, who are the most loyal customers of your superstore? So in which way you can define the most loyal customers in your superstore? So one option is you can check the repeat purchase amount for a particular customers that you have already calculated in the frequency analysis section. Okay, then you can check for the customers who have spent a lot and which you can and contributed a lot to your profitability, and this thing can be measured by the variable order underscore value underscore euro, and you have already calculated this in the previous lesson. And one more measure is remained, which is the cost. You can also consider the amount you have to sacrifice to retain a particular customer, and by the aggregation and consideration of these three measures, that are that repeat buying purchase and the profitability and the cost, you can finally find out the most loyal or profitable customers in your superstore. So you have done all the calculation, right? But and now through the help of pivot table, we are going to aggregate all this information in a particular table and a graph to provide you a significant sense of exploratory data analysis. Let's see how we can do so with the help of ChatGPT. So go to ChatGPT and ask, give me a Python code to make a pivot table by one product categories. For example, we are dealing with customers, right? But I am asking ChatGPT to provide any code based on product categories, which will revise while dealing with the code in our Jupyter Notebook environment. However, I have also said that based on median sales cost and the number of counts of each category. So I am actually telling ChatGPT to provide me the code for pivot table. I have specified that I want the pivot table based on the product categories. In simple words, I define the categories list, and I have also defined the numeric values that I want in this particular pivot table and its forms, which is median sales and median cost. And I have also specified that I want the counts of each category and attach this particular result within my pivot table. So now run the command. So here you can see the code. So at first ChatGPT created a sample data. Moving to the first line of or block of code, here you can see it creates a variable called pivot underscore table, and it started with specifying the data frame name or data frame variable name with which the dot pivot table Python method is used to calculate or create the pivot table. And within the function, we can see it specifies three things: index, values, and aggfunc. In other words, aggregate function. However, in the index, you can see it defines the product category because we want the list of categories. And in the next one, you can see the values. Here, the values are the list of numeric variables. You can see that sales and cost are defined. And in our case, the sales represent the order value euro variable and cost is cost. And the aggfunc, where you can see it started with a second bracket and finished with a second bracket as well. And in the aggfunc or aggregate function, you actually specifies the calculation method for each variable for the result you want to see within your pivot table by each product category. You can see for the sales, it defines the median. For the cost, it also defines the median, and for the category, it defines the count or frequencies. In the second block of code, you can see here, it also defines the pivot table, and actually it renames some columns name to provide a meaningful name for the columns that in a pivot table. For example, it used the dot rename Python method on the pivot table, and within the function it specifies its columns, and you can see the specification is made between the second bracket, and you can see that the sales is a variable and it assigns the name for the variable sales as median underscore sales, and the assignment of new name of a particular column is made by this particular colon sign. And similarly, you can see for the variable it assigns the name median underscore cost, and for this variable of product category it assigns the name count. However, that's all. Now if you can copy the codes, go to Jupyter Notebook, paste it here. Now you have to make some revisions. So at first you have to change the product category to the customer underscore name because we are finding out the repeat purchase or order value or cost for our customers, not our product category. Then you have to assign the correct variable name, no, instead of sale, which is our order value euro, and we have to correct the spelling of cost. Now you have to define the aggregate function. So for order value euro, instead of sales, we are assigning the median function. For the cost, we are assigning median, and for the customer name list, we are assigning count, not product category. In the next code, you have to assign the new name for our variable names. So for order value euro, we are assigning a median underscore sales. For cost, we are assigning median underscore cost. And for customer name, we are assigning count. So now everything is okay. We have to remove the print function because we do not need it to show our result. Run the code. So here you can see the list of customer names, the median cost, their count, and the median sales. But from this table that contains approximately 75 rows, it is very tough to make decisions about your most loyal or profitable customers, right? So in that sense, you can visualize your result. To visualize your result, you can go to ChatGPT and get the best code. So here you can say, right, give me a Python code to visualize the results in pivot underscore table in the above task. That means I am asking ChatGPT to give me a code to visualize the result in our pivot table that it just made for you. However, I have also added plot count in a line and rest in a bars. That means I am asking to give me the visualization in which the values in a count will be plotted in a line chart and the rest such as the median values of order value and cost will be plotted in a bars chart. However, run the command. So you can see that it imported pandas, matplotlib and seaborn. You have imported all this in your Jupyter notebook. So you do not need to import it again. It created the example data. It created the pivot table. However, we have done all of these things. We just need these particular lines of groups. So here you can see it created a figure size with some axis, and you can see it used the dot subplots to create the subplots within a particular figure, and it defines the figure size 12 for width and 6 for height. However, in the next block of code, here you can see it uses the dot line plot Python visualization method, which derived from the Seaborn library. As you can see, the SNS is used, within which it defines its source data, which is pivot underscore table, and the variable count. That means the source data is the count list of values which we got in our pivot underscore table. In simple word, this particular variable. However, next you can see that it defines the markers in your line chart like this one. It defines the axis within your figure, which is axis 1. And it defines the color, it defines the level, etc. However, in the next line of course, you can see as this particular plot will be visualized in the axis 1 figure. So for the axis 1, at first it sets the X level, product category, we will revise it to our customer names. Then it defines the Y level, and the Y level is count, and the color is this one, tab blue. And for the tick params, it defines the axis Y and the colors tab blue. In the next block of code, you can see it created a second Y axis for the bar plots. That means in a figure, it will show you two y-axis. For one y-axis, which will be plotted in axis 1, we'll see the counts, and for another or twin y-axis, we'll see the median values. Here you can see the another axis, which is axis 2, and the another axis is a twin or copy of axis 1. For this, the twin x Python method is used. In the next block of code, here you can see at first the data of median sales and median cost from the pivot table is filtered out in a two-dimensional array, because you can see the two third brackets are used, and on this data you can see the dot plot is used, and the kind of the plot will be bar, the axis will be axis 2, the width of the bar will be 0.3, and the colors will be tab orange and tab green. However, you can see the alpha. Alpha is used to defines the intensity of your color, which is the maximum intensity is 1, and you can see that it is set to 0.7. For the axis to y level, the y level is set to values and color is black. You can see the tick params is also y and color is black. And for the last block of code, you can see the plot customization, where it provides the plot title and it added the legend for axis 2, and you can see the lock where it defines the upper left, which is the actual position in which within the figure you want to see your legend. And you can see the levels of your legends, which are median sales and median cost. And finally, the dot show method is used to show your graph. However, copy the code, go to Jupyter Notebook, paste it to a new cell. Okay, so we will delete these extra things. So the first block is okay, no problem with it. For the second block, you can see the variable name is count, and here the variable name is count, so no problem. The marker and other attributes are also okay. And we have to change the name, because here the label will be customers names. Okay, the y level will be count and the colors are okay, everything is okay. For the third block, you can see the column names are median sales and median cost, as you can see in our pivot table as well, and everything is okay. But in the last block, you can see for median sales cost and count by product category, not product category, is a customers. So we want to see the median sales cost and count by customers. We can make it product purchase by customers, not count. And then you can see the legend. Okay, legends are fine. Now just run them. So here you can see the graph, and you can see the graph in a very cluttered way, because there are approximately 75 customers, and you can see the names are very cluttered of these customers that presented in a graph. To define the loyal customers, we do not need the list of all the customers, because if we at first select a threshold measurement to find out the most loyal customers, which is the repeat buying process, because the person who comes to you and purchase products so frequently, definitely your loyal customers, and a person who comes to you at a time, once at a time, and purchase a big amount will not be considered at that much loyal to your store. So the main threshold can be defined as your product purchase frequency, right? So let's at first sort our data by the highest product frequency purchase. and then we can select the top 5 or top 10 customers, and among which we can make the comparisons to find out the optimal number of loyal customers considering both median cost and median sales. To do so, we have to sort our pivot tables by the function sort underscore values, and you know how to do it in our sorting lesson. So we are going to sort by count, and we are going to sort by in a descending format. So we'll write ascending is equal to false. Load this particular result to sorted underscore pivot underscore table. So let's copy the variable name and paste under of the code and run the. So here you can see the sorted result of our pivot table, and you can see the customers with highest number of frequencies with their median sales and their median cost. Now we can choose the top 10 customers to compare with each other, right? So to choose the top 10 customers, we just need to filter out by adding a third bracket, and you have to select the range of your selection within the third bracket, which is 0 to 10, right? So we'll load this information to top underscore 10. Now, if I copy the variable and paste it here, you can see the top 10 customer list as per the purchase frequency of product purchase, their median cost and median sales. Now let's visualize this particular result in our plot to get the most loyal customers. We just need to change the source data. So wherever you can see the pivot underscore table, you have to ensure the top 10, because we are now collecting the data from the top 10, right? So everything will be fine. Just we need to revise the pivot underscore table with the top 10. And here you can see the pivot underscore table. So make it top 10. So everything is okay. Now run them. So here you can see the result of our graph. We can enhance the figure size to suppose 30 to 10. And here you can see our visualization. If we zoom in, you can see that Johns and Sons is our customers, approximately approximately highest order value, and the purchase frequency is also very higher. The order value and the cost are relatively higher for the top 4 customers, but comparatively the purchase frequency except the first two is very lower. And even you can see the last, the Larkin Cooler, who is also the customer of the superstore. And from the line graph, you can see the purchase frequency is very, very low, but the order value is very high. So if we consider the all scenario, you can see that the higher the order value or the median sales, the higher the cost. So there is a positive association, or there may be a positive association between them, but the differentiation is actually happen based on the product purchase frequency. Because if you multiply the purchase frequency with their amount of the Johns and Sons and Hassel and Statement, the first two person or the first two customers, you will see that total sales amount will be very high compared to the person Larkin Kohler, because the if we multiply the frequency of his product purchase with its value. So in that sense, we can take our first two persons like Johns and Sons and Hassel and Statement as our most loyal customers. We can provide various rewards and various important recognition to them to keep them motivated and make a very good relationship with our customers. So this is how we can use the help of pivot table and all other techniques we have learned so far to make some very useful, significant information, insights for your data. So that's all for pivot table. Thank you. Hello everyone, welcome to the new lesson. So you have dealt with frequency analysis for categorical variables, descriptive analysis for numeric variables. You learned how to use the group by method to implement your analytical skills for both categorical and numeric variables. And you have already learned the utilization of pivot tables for making decisions based on a big picture on the analysis you made. However, now you are going to measure the relationship between the categorical variables. In other words, you are going to see the way of dealing using cross tabulation. In the cross tabulation, you will be able to make comparative analysis, relative analysis, as well as you can also make some decision and recommendation by the utilization of one categorical variable to other. So let's see how we can do so by answering the data analytical question. So at first you can see this particular question where I can see that it asks under which sales manager. So we don't know the exact sales manager. Which product category has the highest sales value? So here we can see the application of two categorical variable. One is sales manager, another is product category. So we want to see the sales manager that contributed his utmost effort to sell a particular product category most. To do so, we will require the Python code for cross tabulation. So we will go to ChatGPT and ask ChatGPT the thing. So you can see I write, give me a Python code of cross tab for two categorical variables and a visualization of the cross tabulation. So you can just hit enter. So here you can see the codes. At first you can see that ChatGPT imported Pandas, Matplotlib and Seaborn that you have already dealt with. You can see it created example data. We do not need it, but we need at first this line of code to make a cross tabulation for our two categorical variables. You can see the cross tab variable within which the cross tabulation is loaded, and the dot cross tab Python method is used, which is derived from the Pandas library. That is why you can see the pd dot cross tab is written to make the cross tabulation of the two categorical variables. And within the function, you can see that two categories are defined by filtering out the categorical variable from the data frame. So we can just easily copy the line of code, go to Jupyter Notebook, paste it here, make some revisions. At first, it will be final underscore df. So we'll revise df wherever we can see by final underscore df. Our first category is sales underscore manager. If we go to the data and check it, yes, sales underscore manager, and our another categorical variable name is category. So we'll replace it by category. Now if I copy and paste it here, you can see our cross tabulation chart. So from the cross tabulation, you can see the sales manager, this first sales manager contributed most to clothing and games type products. You can see that Othello Boas, our sales manager, who contributed most to appliances and electronics product. So this way you can measure and identify the sales manager who contributed to which product category the most. However, let's visualize the result. So for visualization, you can see that as per our command, ChatGPT provides us the code. Here is the code. So of course, the code at first defines the figure size, then it uses the heat map. So heat map is another type of visualization and specifically used to visualize the cross tabulations type data. However, it is derived from the Seaborn, as you can see the SNS is used, within which we can see at first the cross tab, which is the variable that includes our cross tabulation result. It defines the anode is equal to true. Here the anode means the numbers here you can see by 228 will be shown to on our graph, and the C map or the color map is yellow, green, blue. That means the higher the number is, the more the color will be blue, and the lower the number is, the more the color will be yellow. And for medium, the color will be green. And after that, you can see the title is set, X level and Y level is set, and finally the dot show method is used to show the plot. So if we copy and paste it here, and we have to just change our category name. So our category 2 was our product category, right? So we'll write here product category, and our category 1 was sales managers. So now run the code. So here you can see the heat map. So from the cross-tabulation heat map, you can easily identify that which sales manager contributed most to which particular product category. So you can see that our first person or first sales manager contributed to the clothing and games and appliances. Maximaro, sales manager who contributed most to clothing brand. Othello Boys contributed most to appliances. But if you choose a particular product category, suppose smartphones, you can see Othello Boys contributed to the most. If you select electronics, you can also see that for electronics product category, Othello Boys contributed more, and for clothing you can see that our first Tumasian sales manager contributed highest. So in this way you can make some very good insights from your data. Proceed to the next. In the next question, you can see it asked, in which country did a particular sales representative achieve the highest sales volume? So it is actually asking for number of sales a particular sales representative made in a country. And so it's a very easy thing as well. We just need to copy this one. At first, to create the cross tabulation, I will rename it to cross tab for sales underscore rep, and I will replace this by the sales underscore rep cross tabulation. We have to change our categorical variable name to sales representative, and here we want to see the country, right? The performance of sales representative by country. So we defined it by country. Now if you run the code, here you can see a very huge cross tabulation, and in most countries you can see the 0. However, we can make it more simpler if we visualize the data in our heat map, right? So if we create a new cell and plot the data in our heat map, to plot it, we have to make sure we are replacing the cross tab by our cross tab underscore sales underscore representative, wherever we can see it. So everything is okay, just we need to rename the X level, so which is our country in our case, and our sales representatives. Now run the code. So here you can see that for a particular country, the performance of sales representatives, you can see in Denmark, there are Karo Morfight and Colin Magnus are the sales representative who contributed the most. If you select the France, in France, you can see Anita Wokes, our sales representative who contributed to the most. And in Portugal, you can see crystal holes, our sales representative who contributed the most. So this is how you can make cross tabulation and can derive some significant insight very easily with the help of Python and ChatGPT. That's all. Thank you. Hello everyone, welcome to the new lesson. And in this lesson, we are going to see the application of correlation analysis to find the correlation between the numeric variables to get some relational insights to see is there any relationship between any numeric variables. However, you can see our question is find the relationship between order value, cost, and refund amount. So we want to see how the order value reacts when there is an increase with in cost or refund amount. However, we can also measure how refund amount behaves when you can see there is a decrease in order value or cost. So you can define such relationship in your numeric variables after completing this lesson. So we'll go to ChatGPT and we'll ask. So we can say, right, give me a Python code for calculating correlation and visualize in a correlation matrix. Okay, so I can also define the number of variables I have. So I will define that for three numeric variables. Now run the command. So here you can see the code. At first, it imported the necessary libraries and created the sample data. We can ignore it. We need this tiny line of code to calculate the correlation and these lines of code to visualize the result. However, you can see the correlation underscore matrix is the variable within which the result of correlation is loaded. You can see the df is used to on which the correlations are calculated. We will use the final df obviously, and the dot corr is a Python method to calculate the correlation among the variable in a particular data frame. However, in the next lines of code, you can see that the figure size is defined, then the heat map is used, and here the data is correlation matrix, the title is set, and finally the plt.show. So now you can copy the code, go to Jupyter notebook and paste it. We have to change it to final underscore df, and we have to filter out our variable names because we are not measuring the correlation on our entire data frame. Rather, we are measuring the correlation for order value, euro, and for cost and for refund. Now it is okay. So let's run the code. Here you can see the correlation matrix. So in a correlation, the maximum number of coefficient value can be 1 and the minimum number can be 0. So for our cutoff point is 0.5. You can define weak relationship if you can see any correlation coefficient value is going near 0 and most importantly below 0.5. Or you can define any correlation coefficient as a strong correlation if you can see the correlation coefficient value is going towards 1 or specifically you can say higher than 0.5. Or if you can see any correlation coefficient around 0.5, you can define it medium correlation relations. However, you can see the correlation matrix. If I define the relationship between cost and order value, you can see the relationship is 0.99. Very strong relationship. You can also see the relationship between refund and order value is 0.93, which is also very strong. And similar for others. You can see the relationship between refund and cost is 0.92. In correlation, you can get two types of correlation value. One is positive, another is negative. If you can see any minus sign beginning the correlation coefficient value, it will indicate there is a negative relationship between those values. or for any positive value, you can say there is a positive relationship between those values. Suppose you can see a strong positive relationship between refund and order value. That means you can say when the order value increases, the amount of refund increases. Or you can say when the order value increases, the cost is increases. But suppose, just suppose and think that there is a negative relationship between refund and cost. Then you can say when the cost increases, the refund decreases. So this is how you can measure the relationship. So after all, you can see there is a relationship between the more you get the order and the more cost you bear, the refund will definitely increase. So that's all for now. Thank you. Hello everyone, welcome to the new lesson. And in this particular lesson, you are going to understand three basic important measures of hypothesis testing: confidence level, significance level, and p-value. These are the three important measures of hypothesis testing that is necessary to understand before conducting any hypothesis testing to know how to make decision and conclusion regarding a hypothesis you said, such as null or alternative hypothesis. So let's first understand what does mean by confidence level. So you can see the confidence level is the probability that a statistical estimate such as a mean or a proportion, percentage, etc. from a sample will fall within a certain interval of the true population parameters. A 95% confidence level, for example, implies that if we were to take many samples and calculate a 95% confidence interval for each sample, we would expect about 95% of those intervals to contain the true population parameters. I think you are being confused, right? But don't worry, here is a very simple example for you to understand the confidence level very clearly. So you can see that if a survey reports a mean income of $50,000 with a 95% confidence interval of 48,000 to 52,000, it actually means the researchers are 95% confident that the true average income falls within that range, or this is the range within which the true average income you can find out if you had the data set of entire population instead of a sample data. Next, proceed to the significance level. So the significance level is like a decision threshold in statistical testing. It's a way to set a standard for how confident you want to be in your conclusions, taking into account the possibility of making mistakes. Imagine you are trying to decide whether a new medicine works. The significance level is the point at which you say, if the confidence is beyond this level, you will conclude the medicine is effective, otherwise you will not. When conducting a hypothesis test at a 5% significance level, you are setting a threshold point to take a risk of making mistakes or wrong decision on your hypothesis. By this, you are taking a chance of being wrong on making a decision up to 5%, not more than this. However, the level of significance can be 5%, 2%, 3%, or 1% as per your subject matters. However, the worldwide recognized and accepted significance level is 5%. And now let's proceed to the next measure, which is p-value. When you are doing a statistical test like comparing groups or measuring an effect, the p-value helps you decide whether to accept or reject a null hypothesis. If the p-value is small or less than your chosen significance level, and often 0.05 or 5%, you reject the null hypothesis and conclude on your alternative hypothesis. Or if the p-value is high or higher than your chosen significance level, often 0.05 or 5%, you reject the alternative hypothesis and conclude on your null hypothesis. In our previous example, that our null hypothesis depicted the new teaching method has no capability to improve students' performance, and the alternative hypothesis was the new teaching method has the ability to improve the students' performance. And after conducting the analysis, if we see that our p-value is less than our significance level, suppose 0.05 or 5%, you have to reject the null hypothesis and accept and conclude that the new teaching method has the ability to improve students' performance. That's all. In the next lesson, you are going to learn the complete hypothesis testing steps, and there you will be able to make other confusions clear very easily. Thank you. Hello everyone, welcome to the new lesson, and you are going to one step ahead from the practical data analysis to the inferential data analysis, in other words statistical data analysis. So let's first understand what does statistical analysis hypothesis testing mean. Then you can proceed to the practical statistical data analysis and understand when to use it, how to use it, and how to make some significant insights as per the statistics. Statistical data analysis is very important, and you can say the first priority before building some relationship, building some significant predictive model as for your subject matters, because statistical data analysis provide you some significant interpretation, some patterns, some insight, some relationship among the variables you have in your data, that will help you to build a strong predictive model for your subject matters. However, you can see in the screen some basic points regarding statistical analysis. At first, you can see that statistical analysis is a method of some steps. In simple words, the steps are collecting the data you need, organizing those data set, analyzing the data set, interpreting the result you have from your analysis, presenting the information or the analysis in a report, and draw conclusions from your data. However, it also involves using statistical techniques to extract meaningful patterns and insight from numerical information or the numerical data. We can take an example for applying statistical analysis in a situation you think like a school implements a new teaching method in one of its mathematics classes, aiming to improve students' performance, right? The school administration is interested in knowing whether the new teaching method has a significant impact on the average exam scores compared to the traditional method. So this is a situation or scenario where you can use the statistical analysis and you can prove whether the current or modern teaching method has the ability to improve the students' capability compared to the traditional teaching method. The goal of statistical analysis is to make inferences about a population based on a sample of data drawn from that population. There is a question that what does mean by inferences about a population based on a sample data, right? Don't worry, you have to understand about population and sample, and then you will be able to easily get the meaning of inferences in this particular sentence or the goal of statistical analysis. So let's proceed to the next thing, the population versus sample. So in this slide you can see that the population is defined as the all households in the city, and the sample is defined as the 500 randomly selected household. Imagine you are interested in studying the average income of all households in a particular city. The entire set of households in that city represents the population. Every household, from the smallest apartment to the largest mansion, is the part of this population. However, since it might be impractical and time consuming to collect income data from every single household in the city, you decide to take a sample. You randomly select 500 households from different neighborhoods and income brackets. This subset of 500 households represents your sample. So this is a very easy and clear differences between population and sample. And let's proceed to understanding what does inferences mean. To understand what does inferences mean, you have to understand the hypothesis testing. So hypothesis testing is about making some predictions or inferences about a population based on a sample data. Actually testing a hypothesis or claim about a population parameter using sample data, which helps you determine if there is enough evidence to reject a null hypothesis for an alternative hypothesis. Suppose the scenario: a school wants to implement a new teaching method to improve its students' performance, and in this particular scenario you can generate some claims or some inference or some hypothesis that either the new teaching method has the capability to improve the students performance, or the new teaching method has no capability to improve the students performance. So here you can make two kinds of hypothesis, two kinds of inferences, or two kinds of claims as per your scenario, right? So in hypothesis testing, you are going to use your sample data that represents your population data to make the predictions or inference that the hypothesis you made, the new teaching method has the ability to improve students' performance, is true or is false. Or does it work in your population, does it not work in your population as per the sample data you have. So this is actually means the hypothesis testing or inferencing about population based on a sample data. You can see in the last line of this slide that the hypothesis testing helps determine if there is enough evidence to reject a null hypothesis for an alternative hypothesis. So let's understand what does mean by null and alternative hypothesis. So null hypothesis is a statement that there is no significant difference, effect, or relationship in the population. It often represents the status quo or default assumption that there is no change or no effect. Suppose you can bring an example as per our scenario of new teaching method to improve students' performance, where the null hypothesis will be the new teaching method has no significant impact on the average exam scores compared to the traditional method. So let's understand what does alternative hypothesis mean. Okay, unlike the null hypothesis, the alternative hypothesis is a statement that there is a significant difference, effect, or relationship in the population. It often represents the status quo or default assumption that there is a change or an effect. And if you bring the same example for the measuring of capability of new teaching method, in this sense, the alternative hypothesis will be the new teaching method has a significant impact on the average exam scores compared to the traditional method. So that's all about understanding hypothesis testing, and in the next video you will see some more measurement to practically conduct that hypothesis testing. Thank you. Now you are going to see the step-by-step process of conducting a hypothesis testing or statistical data analysis. All the statistical data analysis or hypothesis testing begins with a scenario. So here you can see the scenario again, and the scenario depicts about a school that implements a new teaching method, and it is aiming to improve students performance, and the school administration is interested in knowing whether the new teaching method has a significant impact on the average exam scores compared to the traditional method. However, Second steps will be to determine your null and alternative hypothesis. You can see the null hypothesis is the average exam scores of students using the new teaching method are the same as those using the traditional method. So there is no difference. Alternative, the average exam score of students using the new teaching method are different from those using the traditional method. So there is a difference, right? Okay, so we have developed our hypothesis. In the next steps, we have to choose our significance level, or the probability or the maximum probability at which we are willing to take risk, not more than this, to consider our decision may be false. However, you can see we have defined our significance level as 5% or 0.05 as per the worldwide accepted threshold. Proceed to the next slide. You can see our next step is to determine or ensure the normal distribution of our numeric variables. So, normal distribution or bell curve is a fundamental concept in statistics and probability theory. It describes a symmetric bell-shaped probability distribution characterized by the certain mathematical properties. You can see here three graphs. So at first you can see this graph. In this graph you have defined a cross sign indicating this particular graph is not the normal distribution, or the graph doesn't follow the normal distribution. You can see the distribution is slightly right skewed. That means the peak of the distribution is not in the middle of the graph, rather the left side of the graph, and the slope is higher at the right side of the graph. So in this particular scenario, we say such distribution as positive or right skewed distribution. You can see another graph here with a cross sign indicating this is also not a normal distribution, because the peak is at the right side of the graph and the slope is higher at the left side, indicating this is a left skewed or negative distribution. And you can see this particular graph. This is the graph that actually follows the normal distribution or bell curve. You can see a blue color curve which is called the bell curve, and you can see the peak of the distribution is at the middle of the graph and the slope are approximately equal at both sides. In this particular sense, you can say or conclude the distribution of this particular variable is normal distribution. Before testing any hypothesis, the numeric variable must follow the normal distribution. So the distribution must be checked, and if it does not follow the distribution, several techniques you will learn in the practical session to apply to transform the distribution near normal or appropriately normal. Proceed to the next step. In this particular steps, you are going to select the statistical test required for the analysis to test the hypothesis. So you can see a table. In this particular table, I have provided the three kinds of hypothesis you will deal mostly in your work life while dealing with data, and you will also use these three types of analysis most. You can see the first hypothesis where I say that there is a significant difference in something among two or more groups. So you are measuring the difference in something among two or more groups. In this particular sense, you have to use the one-way ANOVA. However, in our case, the hypothesis is say to make any difference in the students' performance scores or exam scores between two kind of scenario. One scenario or one group that has the numbers or exam scores of students for new teaching method, and another group has the number of students exam scores for traditional teaching method. So in our sense there are two groups and we are measuring the difference on students' performance. So we are about to conduct the one-way ANOVA as per our scenario. So the selected statistical test as per our scenario will be one-way ANOVA. If you find any hypothesis like there is a significant relationship between or among numeric variables, you have to use the correlation test. Or if you see you have to measure the significant impact, influence, effect of one or more variables to another variable, you have to use the regression analysis. You will learn more about such statistical tests in the practical lessons. Proceed to the next slide. You can see the next step is to make decision, where you examine the p-value obtained from the statistical test. If the p-value is less than a chosen significance level, and in our case it is 0.05, we will reject our null hypothesis. And finally, we will make conclusions. So if the null hypothesis is rejected, it suggests that there is a evidence to support the claim that the new teaching method has a significant impact on average exam scores compared to the traditional teaching method. And if the null hypothesis is not rejected, it indicates that there is insufficient evidence to conclude that the new teaching method is different from the traditional method in terms of average exam scores. So this is the complete steps of conducting hypothesis testing. And in the next part, you are going to learn how to apply the one-way ANOVA, the correlation test, and regression analysis to derive some insight based on some hypotheses as per our datasets. That's all. Thank you. Hello everyone, welcome to the new lesson. We are about to proceed to the practical implication of several statistical analyses like one-way ANOVA, correlation test, regression analysis, etc. But before proceeding to any statistical data analysis, it is necessary to check whether the numeric variables that we are using in our statistical tests follow the normal distribution. So in this part of this course, you are going to learn how to check the distribution of each numeric variables that you are using in your statistical analysis. And if you found any numeric variables not normally distributed, then I will show you the most followed methods of transformation from a not normal distribution to a normal distribution. So we will check the distribution of three numeric variables in our data, which are order value, costs of goods sold, and the amount of refund. So if we found any variable that does not follow normal distribution, we will apply these methods of transformation to see which particular method provides us the best normal distribution of the not normally distributed variable. So at first, let's check whether our three numeric variable follow normal distribution. To do so, we will go to ChatGPT and we will ask ChatGPT. So I write, give me a Python code to plot three KDE plots in one figure. So KDE plots is one kind of histogram that provides you the bell curve in your data and the perfect representation of the distribution your particular numeric variable has. And this is a advanced level of Python data visualization for histogram that comes from the Seaborn library. So just run the command for ChatGPT. So here you can see the codes, and let's analyze the code first. So here you can see at first ChatGPT imported the required libraries. At first the Seaborn that provides us the KDE plot function, then matplotlib to define the figure size and other characteristics for a particular data visualization, and it imported Numpy to generate or create a sample data. As you can see here, it mentioned that create a sample data for three numeric variables for the visualization purpose. So we do not need all this. However, we can start our code from here to the final part. So at first you see that ChatGPT creates some subplots, and you know what the subplots mean and how the particular Python method works. And within the subplots it created the figure sizes of this figure. So we can skip this particular line as you know about it. After that you can see that .kd plot is used, so which is a function that generates the plot, and the function comes from the Seaborn library. That is why you can see the SNS is written at the beginning of each kd plot function, and within the brackets of the kd plot at first it defines the data that contains each numeric variable. You can see that ChatGPT created three data for three numeric data or sample data, and it put all the data one by one in the three KD plots, and we will revise or replace this data set as per our three numeric variables: order, value, cost, and refund. And then it levels the distribution or the variables. So we will here we'll put order value as a level in this line, and cost for data 2 and refund for data 3, and it defines whether we will accept any shade. So whether in our graph we want to see the different shades for each variable, and all the shades are true, we will see different types of shades for the distribution of the variables. And finally you can see that from matplotlib title method is used to provide a title for our graph, and it defines the x level and y level. And finally from the matplotlib library .legend function is used, so it is actually used to show the legends in within your graph. So here it is used, and finally the .show method is used. So we just can copy the code, go to Jupyter notebook and paste it here, and we need to make some revisions. So there is nothing to make revisions in the first line of code, but for the first KD plot we have to define our variable. So definitely you know how to do or assign the name of your variable, and you can see that I am doing this in the screen and Jupyter notebook. So you can see that I have filtered out the order value euro from our final df data, and we will provide the label as order values. And for the second KD plot, definitely we will filter out the values from cost variable. So for the same function, we will just replace the order value euro by cost, and for the label we'll put here cost. And for the third KD plot, we'll similarly assign or replace the variable name by a refund. And here you can see from the final data frame we are filtering out the values of refund from the final data frame, and definitely we have to assign the label as refund. So everything seems perfect. Just run the code. So here you can see the figure. So in this particular figure you can see the distribution of our three variables individually, and you can see a legend here. The legends indicate that which particular shades and color of the distribution indicate which variable. So the blue one indicates order value, the orange one cost, and the green one refund. If we analyze the distribution of our variables, so you can see the distribution of refund is nearly normal, but we think there can be some improvement if we apply any transformation. So we will see whether applying transformation on refund will result in most or better normal distribution. For the distribution of cost, you can see it is highly right skewed. You can see the most portion of the data or the peak of this distribution is at the left side, and a huge slope in the right side, which is similar for the order value distribution. You can see there are very high right slope, and indicating the both cost and order value is a positively skewed or right skewed data, not indicating any normal distribution. So for the transformation method must be applied for the order values and cost, and we will see whether applying any transformation method to refund will result in a better solution for normal distribution for this variable. However, this is how you can plot the distribution of your data, and you can analyze whether the distribution follows normal or not normal. If not, you can make decisions to apply transformation. In the upcoming lessons, you will see how to use each transformation method, convert the distribution from not normal to normally distributed data. That's all. Thank you. Hello everyone, welcome to the new lesson, and in this particular lesson we are going to apply the square root transformation on all of our numeric variables to see whether the distribution can be transformed into more normalized way. So to do so, we at first need the code to make square root transformation. So we'll go to ChatGPT and we'll ask, give me a Python code for square root transformation. So run the command. Here you can see the code. At first, ChatGPT imported the Numpy. So Numpy is a library that is must require to make any mathematical or advanced mathematical calculation with your Python code in Jupyter Notebook. So you can see ChatGPT imported Numpy as a short from NP. So whenever we will call NP in our code, that means we are referring to the any functions that derived from the Numpy library. So at first you have to ensure that you have installed the Numpy library by using pip install Numpy, and then you imported the Numpy package. Okay. After that, you can see a sample numeric variable is created and loaded within the data variable. We have our numeric variable. So we just need this particular line of code. You can see that np.sqrt. So sqrt is a function that is used for square root transformation, and this function is derived from the numpy library. That is why np.sqrt is written, and within the function you can see the numeric variable data is transformed. So we just need to copy the code, go to Jupyter Notebook and paste it here. So we have to make some changes. So at first we are transforming our order value. So you can say transform underscore order value, and we can make it sqrt underscore order value to refer this particular variable store the square root transformation of order value variable, and then we have to bring in the values of the variable order underscore value underscore euro. So we have done this as well, and now we can run the code. So you can see the code runs perfectly. However, let's check the distribution at first to see whether the distribution of order value becomes normal. To do so, we'll plot the KD plot, and we'll just copy the codes of KD plot, sns.kdplot function, and then we'll just replace the values of our real variable order value euro by the values of sqrt underscore order value that includes the square root transformed values of our actual variable. Just run the code. So here you can see the distribution. If I refer to this graph, you can see here there was a very long right skewness, but the right skewness is reduced at a most way. So we can say that the square root transformation for order value euro converted it to near normally distribution or normally distributed. Then we will use the square root transformation for another variable, which is cost, to see whether this transformation is able to transform the right skewness to normally distribution. So here we will write cost, and as you can see that we have copied and pasted the function or the code, and we have replaced the order value euro by the variable cost. Now we can copy and paste this small line of code to see the distribution of transformed cost variable. To do so, we have to copy the variable within which we will load the transformed cost variables values and replace it by the previous variables values. And now we need to run the code. So here you can see that the distribution of cost is also converted to near or approximately normally distribution, because the right skewness is reduced as much as possible by using the sqrt function from the numpy library, and we have done this for our variable cost. Now we are going to do the same thing for our refund variable. We have copied and pasted the codes and we need to make some revisions. At first, this particular variable will be called for the square root transformation for refund data, and we have to change the variable name to refund because we are using the refund variable values for the transformation. And for the KD plot, we have to replace the transformed cost with the transformed refund variable values. Now we have to run the code. Oh no, you can see that transformation becomes worst for the variable refund. So the square root transformation does not work properly for the variable refund. If I compare it with this particular distribution, you can see that green one indicating the distribution of refund, it was more normal compared to this particular transformation. However, we are going to use other transformation like logarithmic, box and Johanson's step by step. So in the next lesson, we are going to use the logarithmic transformation in our three variables to see which particular transformation provides us the accurate normal distribution for our numeric variables. That's all for square root transformation method. Thank you. Hello everyone, welcome to the new lesson, and in this particular lesson we are going to see the application of logarithmic transformation, and we want to apply the transformation method in our three numeric variables to see how it transformed our not normal data to most normal distribution. So let's first generate the required code for the logarithmic transformation. We'll go to ChatGPT and definitely we will ask the similar thing to ChatGPT but for logarithmic transformation, in simple log transformation. So I write give me a Python code for log transformation. Just run the command. So here you can see the lines of code, and I think you have noticed one thing. All the codes are similar here except the dot log. Just dot log function from numpy is used to transform the numeric variable to logarithmic transformation and load within the variable transform underscore data, and everything is okay. We have loaded the numpy library, so we do not need to load it again. We just need to copy this line of code, go to Jupyter notebook and paste it here. We need to make some revisions. At first we'll make it log underscore order val, because we are using the transformation for our order value euro. So we have to filter out the values of order value euro within the function of log dot log, and you can see I have filtered out the values of this particular variable from our final data frame. We want to see the distribution, so here we will copy the line of code of KD plot and paste it below here, and definitely we have to replace the sqrt underscore refund by log underscore order value, because we are storing the transformed values of order value euro within this particular variable. Now run the code. So here you can see the logarithmic transformation of order value euro. You can see that the transformation is somewhat good, but we cannot say it better because the distribution or the peak of the data is still near at the right side, and the skewness becomes somewhat higher at the left side. So I think if we compare this particular transformation or sqrt square root transformation on order value provides us the more realistic normal distribution compared to this particular distribution. So we can say that is still the square root transformation providing us the best transformation for order value euro values. Okay, so now we'll check the log transformation for another variable, which is cost. So we'll copy the two lines of code and paste it to a new cell. We just need to at first change the variable name to cost. Then we have to change the variable name to log underscore cost, and definitely we have to replace the log underscore order value by the log underscore cost, because the transformed values of cost variable will be loaded to log underscore cost variable. Now run the code. So here you can see the distribution or transformation of log for the variable cost. You can see the distribution is similar like this, but don't worry or don't get confused. It can be happened, but definitely the variables are different. One is order value and another is cost. And if I check the distribution of square root transformation, you can see still I think the distribution for square root transformation is more realistic compared to the transformation of logarithm for the cost variable, because we can see the peak is still comes to the right side more. The weight of the peak is in the right side of the distribution. Let's check now the distribution of refund variable as per log transformation. So yes, again we will at first change the variable name to refund, and here the variable will be log underscore refund, and we will replace the log underscore cost by the log underscore refund and run the code. Oh no, you can see that the distribution of refund becomes worse by using the logarithmic transformation. You can see the peak becomes very high at the right side and the slope becomes very high at the left side, indicating us a negative, most negative distribution. So we can just reject the logarithmic transformation for the variable refund, and so far we can accept the transformation of square root transformation for order value and cost, and we still do not find any transformation for refund, because so far refund is a variable that still looks simply good without any transformation. However, in the next lesson we are going to use the box cox method for the transformation for our three numeric variables. Thank you. Hello everyone, welcome to the new lesson. In this particular lesson, we are going to apply the box-cox transformation method to our three numeric variables, order, value, cost, and refund, to see whether this particular transformation technique provides us the most accurate transformation of normal distribution of our numeric variables. So let's at first generate the required Python code. We'll go to ChatGPT and definitely will ask the same thing to ChatGPT, but for box cox transformation. And you can see here, you can see the lines of code. So at first you can see that along with numpy, the scipy, from the scipy library, the states package of Python is imported. States is a particular package which is required for any statistical calculation, and here the boxcox is a method of transformation which is mostly considered as an advanced technique of transformation. Definitely you have to ensure that you installed the scipy and states in your Jupyter notebook by using pip install method, and you have imported this library. So you can see I have copied and pasted the library. This is a particular line of code we need. You can see there are two variables. One is transform underscore data and lambda underscore value. The transformed underscore data is a particular variable within which the boxcox transformed data will be loaded. So at the right side of the equation sign, you can see our code. You can see the dot boxcox method is used, which is a Python method derived from the states package to transform the numeric values into boxcox transformation, and within the brackets of this function the numeric variable data is loaded. However, we will replace this data by our numeric variable. That's all. we just need to copy the code, go to Jupyter Notebook and paste it here. We just need to make some changes. At first we will make it box cox underscore order well. Then definitely we have to replace the data by our variable order underscore value underscore euro from our final underscore data frame. And then we have to copy the line of code for KDE plot and paste under it and replace the log underscore refund by the boxcox underscore order value, because this is the variable within which the transformed values of our variable will be loaded following the boxcox method. Run the code. So here you can see the transformation. We can see the more accurate transformation for normal distribution compared to the square root transformation of the order value euro. So we can refer to this transformation by saying that for the order value euro, so far the best transformation is boxcox transformation. Then copy the lines of code and paste it to a new cell, because we have to measure the transformation for our variable cost. So we'll replace it by cost, and definitely we'll change the variable name to boxcox underscore cost, and the boxcox underscore cost will be put instead of boxcox underscore order value. Now run the code. So you can see that the transformation of cost for boxcox method is similar to the transformation of square root, as you can see here. So the change is not much significant, but still you can see that the peak is in the middle of the graph compared to the square root transformation. As you can see here, the peak is still near the left side, and the slope of the square root transformation at the right side is somewhat higher than the slope you can see by using the boxcox transformation. So by comparing such small techniques, you can conclude that the boxcox method is still so far best transformation for the variable cost as well. After that, we'll apply this particular transformation method for another variable, which is refund. So we'll change the cost to refund, and we'll change the variable name to boxcox underscore refund, and definitely we'll replace the boxcox underscore cost by the boxcox underscore refund. And now run the code. So you can see that still the distribution of the refund for boxcox transformation is not so much good. The actual distribution is much more better for refund compared to the transformation we have found so far by using square root transformation, logarithmic transformation, and boxcox transformation method. So far there is no best transformation method we have found for the refund variable. In the next video, we will use the Yo-Johnson method for the transformation on our three numeric variables. That's all. Thank you. Everyone, welcome to the last lesson where we are going to apply the Yo-Johnson method for the transformation of our three numeric variables. And in this particular method, we are going to see and make conclusion or identify the most appropriate transformation for a particular variable. We at first need to generate the Python code for Yo-Johnson method. So definitely we will use the same command, but for now the command we need for Yo-Johnson transformation method. So run the command. Here you can see the lines of codes, and definitely I think you have identified the similar thing. All the codes are similar, like the codes we have found for boxcox method, except the .Yo-Johnson is used. .Yo-Johnson is a particular method that is also belong to the states package. That is why the state package is imported by ChatGPT, and we have already imported the package, so we do not need it again. So you can see that in the particular line of code, just the change is .Yo-Johnson, and all other things are similar. We just copy the code, go to Jupyter Notebook and paste it here. Definitely we have to make some changes. So at first we'll write yo underscore order val, and within the brackets of yo Johnson function, we'll filter out our variable order underscore value underscore euro, and everything is okay. We just need to copy the line of code for kd plot and paste beneath it, and we have to replace the boxcox underscore refund by yo underscore order variable, within which we have loaded our transformed order value euro values following the yo Johnson transformation. Now run the code. So here you can see the distribution or the transform distribution for order value euro is similar as the distribution of boxcox method for the variable order value euro. So no change. So we can pick either the transformation of yo Johnson method or boxcox method for the transformation of order value euro, because both are similar. However, now we'll copy the similar line of code to test the transformation for cost variable. So we'll change the order value euro to cost, and the variable within which the transformed cost values will be loaded is yo underscore cost. Definitely you have to replace the yo underscore order val by yo underscore cost, and now you have to run the code. You can see the transformation or transform distribution is similar for the cost variable we have found for the boxcox method, but I think the yo Johnson method is more perfect compared to the boxcox method, and you can use one of them, no problem. In my case, I will definitely use the yo Johnson transformation method for the cost variables transformation. And finally, we have the variable for refund, and for which we have found no best transformation technique, and definitely we have to change it, but change it to refund, and the variable within which the transformed refund values will be loaded is yo underscore refund. We will replace the yo cost variable values by the yo underscore refund, and now run the code. You can see the distribution is similar as boxcox, so we have found no transformation for the refund variable, so we have to keep the actual variable or actual values for the refund variable, which is much more appropriate compared to the result we have found by using square root transformation, logarithmic transformation, boxcox and yo Johnson transformation. So at last we can make decision that for the order values euro, we will use the boxcox transformation methods values. We will use the yo Johnson transformation method values for the cost variable, and we will use no transformation for the refund variable. So that's all. In the next part of the course, you are going to use these transformed variables or the actual variables of refund to test several statistical analyses such as one-way ANOVA, correlation test and regression analysis. That's all for now. Thank you. Hello everyone, welcome to the new lesson, and in this particular lesson we are going to apply the one-way ANOVA statistical data analysis to answer the first statistical question, as you can see here. So let's see what is the scenario as per the question given. So the question asked, is there any significant difference in the cost of goods sold among the three types of devices used by the customers while placing an order? Okay, so as per the question, you can see the question asks to find any significant difference in the cost of goods sold among the three types of devices. And for a situation that asked you to find a significant difference on something based on two or more groups, then you have to use one-way ANOVA. So as per the question, you have to use one-way ANOVA. So this is proved. And then we have to define our hypothesis. Okay, so the null hypothesis will be there is no significant difference in the cost of goods sold among the three types of devices And the alternative hypothesis will be there is a significant difference in the cost of goods sold among the three types of devices. So definitely we want to see the null hypothesis as rejected hypothesis. However, for this we have to define our significance level, and the significance level will be 0.05, which is widely accepted. Then you can see we have normalized our variable, and you know that the Yo-Johnson transformation for the variable cost we have defined as the base transformation for normal distribution. So we'll use the yo underscore cost variable. We have to at first add this particular variable within our data. So let's add it first, and to add this particular variable, you know what to do because I have shown you how to add a particular variable or replace any variable in the missing values. So at first we will define our data frame, and we will filter out the new variable name, which is yo underscore cost. So in this particular variable name, within this data, we are going to load the values given in the yo underscore cost variable. And now we will run the code. You can see the code runs perfectly. So let's check the first 5 rows of our data set, and at the last column you can see that u underscore cost variable is added within our data frame. So this is how you can add the variable within a data. Now we are going to generate the required Python code to perform the one-way ANOVA analysis, and we'll go to ChatGPT to do this. You can see I write, give me a Python code for one-way ANOVA, and I will run the code. At first, ChatGPT imported the states packages from the SciPy library, and we have already imported it, so we do not need to import it again. Then it created 3 sample data for 3 groups. However, we have our 3 groups, and the groups are PC device type, mobile device type, and tablet device type. And the numeric variables is cost and its values. However, I will show you how to filter out the data, and I think you already know because I have taught you about it, how to filter out a particular data frame as per some condition. No problem, I will show you it again. And after that you can see the main line of code to calculate the results of one-way ANOVA. You can see the 2 variable is given here, f statistics and p value. So f statistics will include the results of one-way ANOVA except the p value, because the p values will be loaded in this particular variable. We need the p-value to be less than our significance level 0.05 to reject the null hypothesis. However, this particular portion of the code will provide you the required p-value and the f statistics or the statistics results of one-way ANOVA. You can see that .f underscore one-way Python method is used to calculate the one-way ANOVA result, which is derived from the states package. And you can see the states.f underscore one-way is written, and within the brackets of this particular function you can see ChatGPT defines the 3 particular groups numeric variables, and in our case the groups are PC, mobile, and device, and we have to filter out the data. I will show you, no problem. And then you can see that ChatGPT printed the one-way ANOVA f statistics, and the f statistic variable is put separated by a comma. This particular line of code will show you the headline one-way ANOVA f statistics, and along with it you can see the f statistics which will be loaded in this particular variable calculated through this portion of the code, and same for the p-value. After that you can see ChatGPT provided us some lines of code to automatically show the decision and conclusion as per the p-value calculated. You can see the alpha is set 0.05 and loaded in this particular variable alpha, which is our significance level. And then you can see the code, if p-value less than alpha, then print reject the null hypothesis, else print fail to reject the null hypothesis. That means if the particular line of code see the p-value calculated from this code of one-way ANOVA is less than 0.05, it will print the conclusion and decision as reject the null hypothesis and so on, and otherwise it will print fail to reject the null hypothesis and so on. However, at first we'll deal with grouping the data as per our data frame. So we'll copy this particular line of code, go to Jupyter Notebook and paste it here. So let's at first filter out the data as per the 3 device types. So at first the data is PC underscore data, the second group will be tab underscore data, and the third group will be mobile underscore data, in short mob underscore data. And you know how to filter out the data, right? You have learned it, the filtration technique, but let me show you it again. So at first you have to define what is your data frame, and you can see the final underscore data frame, and you have to filter out the as per the condition. That is why you have put a third brackets, and within the third brackets you have to filter out at first the variable that includes the device type. And you know, in our data the device underscore type is a variable that includes the device types. You can see here, you know, this is the portion of code to filter out any particular variable values, and then you have to put the condition. In our case it will be dual equal sign, because dual equal signs are used to completely match a particular condition, and our condition is to match perfectly with the PC. So we'll put the PC in quotation mark. And because all the string written within a particular line of code in Python must be within the quotation mark. Otherwise, only the numbers can be written without quotation mark. Suppose we are filtering something as per the numbers, so we'll just put the numbers, no quotation mark. But as the PC is a object type data, you or text data, you have to put it within the quotation mark. So this particular portion of the code will filter out the entire data frame as per the PC device type and load it within this particular data. And similar for all, just we need to change the device name. The second one is for tablet and the third one is for mobile. That is why I will replace the PC with the mobile. Now we can run the code. You can see the code runs perfectly. And then we can proceed to the next portion of code from here to here. So we'll copy the rest, go to Jupyter Notebook, paste it here, and let's make some changes. So you know that we will use the yo underscore cost variable. That is why we have to filter out the yo underscore cost variables values from each type of data. So for the PC data, I will replace the group 1 by PC data, and from the PC data I will filter out the yo underscore cost variables values, and you know how to do it. And again I will use the same portion of the code, but now for the tablet data, and again I will use the same portion of the code replacing group 3 but from the mobile data. So the first line of code is revised, everything is okay. Just run the code. Here you can see the boom. So at first you can see the F statistics is 1.137 something. The F statistics or the threshold F statistics value is 1.96. However, you can see the result is not optimal. It becomes very clear by analyzing the p-value. You can see the p-value is 0.32 approximately, and which is higher than the significance level 0.05. That is why the result or the final result is to fail to reject the null hypothesis. That means there is no significant difference among the groups. So the final result is there is no significant difference in the cost of goods sold among the 3 device types. So this is how you can use the one-way ANOVA to find significant patterns or insights or decision and conclusion for your data or subject matters. That's all for now. Thank you. Hello everyone, welcome to the new lesson, and in this particular lesson we are going to answer the second statistical data analysis question. You can see the question is there any statistically significant relationship between order value, cost and refund? So we have our 3 numeric variables and the question asks to find out whether there is any statistically significant relationship. That means you can see we have calculated our correlation in exploratory data analysis section. Here is the correlation matrix, and we have found cost highly and positively related with order value euro, like the refund. And now we are going to measure whether the relationship is statistically significant. To do so, we have to make the correlation analysis, and let's at first define the hypothesis. In our case, the null hypothesis will be there is no statistically significant relationship between order value, cost, and refund. And the alternative hypothesis will be there is a statistically significant relationship between order value, cost, and refund. Our significance level will be 0.05 as well. You can see that we have transformed the order value euro and cost variable values as normal distribution. You know that we made a conclusion on order value euro to use the boxcox underscore order value, because we have defined this particular variables values extremely follows the normal distribution. And for cost, we have defined the yo underscore cost variable values that strongly follows the normal distribution. And for the refund variable, we will use actual variable within the actual data final underscore data frame. By combining the three variables, we can calculate the relationship. We'll go to ChatGPT and we'll ask ChatGPT, give me a Python code to perform Pearson correlation test. So Pearson correlation test is a statistical measure that perfectly defines the correlations among the variable and defines whether the correlation is statistically significant or not. However, run the command. So you can see at first ChatGPT imported the same library and packages. We do not need it. We have already imported it, and then created the two example variable. We have our variables, so we can ignore it. And here you can see the line of code to calculate the correlation coefficient and the p-value. You can see that from the states library that .Pearson R is used. The .Pearson R is a Python method to calculate Pearson correlation. And within this particular function, the variable 1 and variable 2, which is the numeric variables, are loaded. And then you can see that the heading Pearson correlation coefficient, here you can see the correlation coefficient variable, which will be calculated and loaded in this particular variable, and which will be shown after this particular heading, and same for the p-value. And as per the p-value, we have the same lines of code to automatically find out the result, whether to reject the null hypothesis or we have failed to reject the null hypothesis. So everything is okay. We just need to copy the code from here to here. Go to Jupyter Notebook, paste it here, and we have to make some changes. So at first you have to define our variables. The variable 1 is boxcox underscore order val. The variable 2 is yo underscore cost, and the variable 3 is final underscore df, and within the brackets and quotation mark refund, which is our actual data, right? Okay, so everything is okay. Just run the code. Okay, hold on, we got a type error, and you can see the type error is Pearson function takes two positional arguments but three were given. That means you can see this particular line is highlighted. So the error is trying to tell us that the function Pearson R only takes two particular values to calculate the correlation coefficient and p-value once at a time. And you can see that we have given the three particular variables. So that is why the error given. No problem. We'll go to ChatGPT and we'll tell ChatGPT that give me a Python code to perform Pearson correlation test for three numeric data. Now run the code. ChatGPT will automatically provide you the codes to calculate for the combination of three numeric data. You do not need to brainstorm how to do it or at all. Here you can see the lines of code. Everything is similar. For this particular lines of code, you can see that correlation 1, correlation 2, and correlation 3. For the correlation 1, you can see among the three variables, three numeric data. At first, the combination of variable 1 and variable 2 is used to see whether there is a significant relationship between variable 1 and variable 2. And then in the correlation 2, the combination of variable 1 and variable 3 is used to see the relationship between these two variables and whether it is significant. And in the correlation 3, the combination of variable 2 and variable 3 is given to see the relationship between these two variables and whether it is statistically significant as per their p-value. And then you can see that the correlation between variable 1, variable 2, and the correlation coefficient will be loaded within the correlation 1 variable for this variable 1 and variable 2 relationship, and which is given here, and the p-value 1 is given. So these two particular lines of code will print out the heading for the correlation coefficient and p-value between variable 1 and variable 2, and the second two blocks of code will print out the correlation coefficient and p-value for the relationship of variable 1 and variable 3, and for the third you can see the for variable 2 and variable 3. And after we will have the decision and conclusion for each combination of variables. For the first block you will see the result of variable 1 and variable 2 relationship, then you will see the result of variable 1 and variable 3, and finally you will see the result for variable 2 and variable 3. However, we will copy the entire code by clicking here copy, and we will go to Jupyter Notebook. We will replace these particular lines of code, and then we have to make some revisions. At first we will ignore these first blocks of code because we do not need it. First we want to see the relationship between order value and cost. That is why I have used the box cox order value and EO cost. For the second correlation, we want to see the relationship between box cox order value and our actual refund data from final underscore df, and we will filter out the variables values like this. And for the next one, or the third correlation, we'll check the relationship between refund and your cost. So that's all. Now you can change some names, like at first we want to see the relationship between order value and cost. For the second one, you want to see the relationship between order value and refund. For the third one, you want to see the relationship between cost and refund. And you can change the similar thing in the conclusion as well. So for the first one, we have got the relationship between order value and cost. Again, we have to write the order value and cost. Then we got the results for the relationship between order value and refund. So we'll replace the variable 1 and variable 3 by order value and refund, and finally we'll replace the variable 2 and variable 3 by the cost and refund, because in the final section we are going to see the relationship between cost and refund. Everything is okay, just run the command and you can see the magic. So at first you can see the correlation between order value and cost is 0.99 and the p-value is 0.0. The correlation between order value and refund is 0.95 and the p-value is 0.0. The correlation between cost and refund is 0.95 also, p-value is 0.0. So you can see the correlation between order value and cost is statistically significant as per the p-value. The correlation between order value and refund is also statistically significant as per the p-value, and the correlation between cost and refund is also statistically significant as per the p-value. So this is how you can calculate or test the relationship to check whether the relationship are statistically significant or not, by the help of ChatGPT and Python and the Pearson correlation test analysis. That's all for now. In the next lesson, we are going to answer our last statistical analysis question by conducting regression analysis. Thank you. Hello everyone, welcome to the new lesson, and in this particular lesson we are going to see the result of this particular analysis question. Let's see what is the scenario. So the question asked, is there any significant impact of order value and cost on the variable refund amount. So you simply know that when you are asked to measure any significant influence, impact, or effect of the variables on other variable, you have to perform the regression analysis. So as we want to measure the impact of order value and cost on refund, we have to conduct the regression analysis. So the null hypothesis will be there is no statistically significant impact of order value and cost on refund, and the alternative hypothesis will be there is a significant impact of order value and cost on refund. And you know the significance level is 0.05, and we have already transformed all the numeric values except the refund because you know what is the reason. However, we will use the yo cost instead of the values of the cost variable, and box cox order value instead of the values of order value. Now we are going to see how ChatGPT provides us the required Python code. So we'll go to ChatGPT and we'll ask. So I write, give me a Python code to measure the impact of order value and cost on refund. Or you can simply write that give me a Python code for regression analysis. However, by specifying the targets will be easy for generating the actual code we need by the ChatGPT. So just run the command. Here you can see the lines of code. At first, ChatGPT imported the most important library, which is statemodels.api as SM. So whenever you can see the SM in your code, you have to refer this particular function used to calculate something in regression analysis comes from this statemodels.api. So this is a particular library that is used to perform any regression analysis or predictive analysis as per the statistics. However, let's at first copy this particular line of code and paste it here. Definitely you have to check whether this particular library is installed within your Jupyter notebook. Otherwise, you have to install it using pip install statemodels.api. After that, you can see ChatGPT created three sample data. One is order value, another is cost, and another is refund. And here you can see the main lines of code. At first, you can see that within the variable x, the constant of the variables is calculated. To calculate the constant values, you can see the add underscore constant is used, which is the Python method to calculate the constant for the prediction as per the independent variable. However, you know that the independent variables are the variables that affect another variable, and here the independent variables are order value and cost, because these particular variables may have an effect on the dependent variable refund, and definitely the dependent variable is the variable which may get affected by the independent variables. You can see that the add underscore constant function is comes from the SM or state models API, and within the brackets of this particular function you can see that np.column underscore stack is used to stack the two variables values, order value and cost, and the constant are loaded to the variable x. After that, you can see that we have a line of code to fit the linear regression model. You can see from the state models API, .ols function is used, and within the function, at first the dependent variable is written, which is refund. Separating by comma, you can see the x, which is the independent variables along with the constant added. And after that, the dot fit function of Python is added to fit the dependent variable and the independent variable within the regression model, and the entire result of the regression model is loaded in this particular variable model. After that, you can see the regression coefficients or results are put within the variable coefficients, and you can see that we have developed our model, and if you use the dot params with your model, you will get all the parameters or statistical results given within the model, and the results are loaded within the variable coefficient. After that, you can see some headings and their respective values. You can see the regression coefficients, which are the first heading, and you can see the second heading, intercept, and separating by a comma you can see the coefficient and with 0. That means we will get the first value of the statistical results, which is imported in the variable coefficient, and the first value is the intercept or constant. I will tell you more about it while explaining the results. And then you can see the order value coefficient, and you can see from the coefficient variable within which the result of regression analysis is imported, and the second variable is taken. You can see it is filtered by 1, and the second variable is the order value coefficient, and the third value is the cost coefficient. And then you can see the summary of the regression model. You can see the print regression summary, and before that you can see a slash sign and n. It is actually used to break down a paragraph or write this particular summary in another paragraph. And after that you can see that print, and within the function the model dot summary is used. So model is a particular variable within which we got the result of regression analysis, and the dot summary is a particular Python function which provides the summary of the regression analysis. We will remove this print because it will be more clearer to you after getting the results of model summary if you remove the print in a structured format. We will just copy the codes from here to here, go to Jupyter Notebook, and then you have to paste it here. So at first you have to define your independent variables. So we will use the box cox underscore order val for order value, and yo underscore cost for the cost variables. Then we have to filter out the variables values refund from the entire data or the final data frame. So this is our dependent variable. Here you can see the x, which includes the added constant for independent variables and the independent variables themselves, and the dot fit model. Everything is okay, just run the code. And here you can see the summary. At first you can see the intercept or constant. That means when there is no sales or no cost, what will be the refund? Definitely there will be no refund. As per the statistical results, the refund will be minus 97,939. So intercept is not a very meaningful thing, so we can ignore it. It just implies that what happens if there is no impact of the independent variables. After that you can see the coefficient of order value, which is 1099. So it actually means that if there is an increase of 1000 order value, then the refund will increase by 1099. So by measuring the coefficient of order value, you can say the impact of order value on refund is highly positive, because when you increase your order value by 1000, your refund is likely to be increased by $1099. After that you can see the coefficient for the variable cost is 106. So similarly, the coefficient value is at first positive. It depicts that if there is an increase of $1000 in cost, the refund will also increase by $106. So you can also conclude that cost positively influence the refund alike the order value. But if you compare the impact of order value and cost by their coefficient values, we can say the sales or order value highly influences the refund compared to the cost. After that, you can see the regression summary. At first we will look at our r squared value. So here r squared value actually provides you the knowledge that the power of independent variables to explain your dependent variable. In other words, the portion within the dependent variable can be influenced by the independent variable. Here you can see the r squared is 0.921. If we multiply it by 100, we got 92.1%. In our case, we can say 92.1% of dependent variable or refund can be explained by our independent variables. Or we can say 92.1% of change within the refund happens because of the influence of order value and cost. After that, we'll go to the final table. Here you can see the table. So x1 is our first independent variable, which is order value, and x2 is our second independent variable, which is cost. Here you can see the coefficient list. Both coefficients are positive, so we can say that both independent variables positively influence the refund. If one of the coefficient becomes negative, then we can say the particular variable negatively influence the dependent variable. Suppose cost negatively influence the refund, so in our case we would get minus 106, and then we could say if there is an increase of $1,000 in cost, the refund will decrease $106. But as both variables of order value and cost positively influence, so we will proceed to this particular result. However, you can see the t statistics and p value, which is mostly important. You can see the p value for order value is statistically significant, as the p value is 0.000, and you can see that the p value is less than 0.05 for the order value or the first independent variable. That is why you can say that order value statistically and significantly influence refund. We cannot conclude the similar thing for the second independent variable, cost, because the p-value is higher than the significance level 0.05. So we cannot conclude that cost significantly and positively influence refund. So the null hypothesis can be rejected for the order value but cannot be rejected for the cost. That's all for regression analysis. After doing the regression analysis, you comes to know what does mean by coefficient of regression analysis. So for a recap, I am telling you again that the coefficient for each independent variable actually defines how the independent variable influence the dependent variable and how much change we can expect in a dependent variable for a standard change of that independent variable. And in our case, if the order value increases by $1,000, the refund increases by $1,099. And as the coefficient is positive, we can see the order value significantly and positively influence the refund. You know the r squared. You can see that 92.1% of change within the refund can be defined by the change or effect or impact of order value and cost. But unfortunately, we can see that for the population, we found that order value has significant impact on refund, but cost does not have the significant impact on refund. So that's all for regression analysis and hypothesis testing. Regression analysis is important to define the significant variables which have significant impact on our target data. I think everything is clear to you. That's all for regression analysis. Thank you. Dealing with errors in Python programming goes beyond just recognizing them. It involves diagnosing the root cause, debugging, and finding appropriate solutions. If I show you these codes, here at first I have loaded the data frame, then run the second portion of the code. We got an error. The error looks much confusing unless you are a pro programmer, right? Here we are trying to impute the missing values of education, then wanted to create advanced visualization of education with age variable of the respondents in the data. However, definitely you can solve the error, but What if it is possible within seconds? Here we need ChatGPT. So in this section, we will use ChatGPT to tell us where the mistakes we made. So we know how to tell ChatGPT to get our job done, right? So at first, we have to copy the entire code. Then we need to go to ChatGPT, and this is the ChatGPT command box. You can see a send a message written here. So at first, we have to write that this is my Python code. Then you have to press the shift key in your keyboard, then click on the enter or return button. This will enable you to get the next line of this command box. However, here we will paste our code. We have to put the second block of our entire command block, which is we need to tell ChatGPT what is the error is showing. So we can say that displayed error, and we can go to our Jupyter notebook and we can copy the error is saying. Just copy it and paste it here. So we have complete our second blocks, and then the final block where we will tell ChatGPT what we need. So at first we want ChatGPT to show us where we made mistakes in our code, right? So I can simply tell ChatGPT that show me where I made mistake in my code. Now hit enter. And you can see that ChatGPT providing us where I have made my mistake, right? So ChatGPT is telling us that the error you are encountering, that is this, is happening because the simple imputer, and it is telling that simple imputer expects a 2D array as the input, and I am providing 1-day array in my education column. I need to reshape the 1-day array into 2D array before passing it into the imputer. Then ChatGPT showing me the example actually where I made the mistakes. It is showing that I need to reshape to a 2D array by using double brackets. It is also saying to use double brackets to select education column as a data frame with a single column, which is effectively a 2D array. Finally, it is telling me the rest of my code looks fine and should work once I have fixed the issue with the input with the simple imputer. In this case, we only need the correct code. So we can easily write that give me the correct code revising my entire code. Now just hit enter. And you can see that ChatGPT providing us the correct code by revising my code where any kind of mistakes might be happened. So you can see the code. It is also providing us some instruction as well. It is telling us to remember to replace df with the actual name of your data frame containing the data you are working with. The main change here, it is the line where the education column is selected for imputation. This ensured that education column is 2D and required the simple imputer. However, let's just copy the code, go to our Jupyter notebook, delete our this code and paste the new code. Now let's run the code. Wow, we got our interactive advanced visualization we wanted from our code. We can see that we got age distribution by education level. We can see this and we can interact with our data and our visualization as well. We have corrected our entire code and we got the correct code by removing the part where we made mistakes. We got what we wanted. And now we will ask ChatGPT to improve our code by making it short and easy enough. So just copy the code, go to ChatGPT, and first of all, tell ChatGPT that this is my code and then paste your code. Then just tell ChatGPT what you want because we are not dealing with any mistakes here. So we do not need to use the second sub blocks in our command right now. So just tell ChatGPT that give me more improve and readable code by shortening my code. Now just hit enter. And now you can see that in some cases our code gets shorter. At first, in our previous code, we imported so many Python packages, but in this code, we just need to import 3 packages from Python libraries. Then we have used 3 lines of code to impute the missing values in the education variable by the most frequent values, in other words, the mode values of education variable. This is converted into 1 line of code by using the dot fill na method, and it is telling to use the mode value in the education variable to replace any missing values. So just copy the code, go to Jupyter Notebook and paste it into another cell. We'll see whether our code works now. Just run the code, and yes, our code works perfectly, providing us the similar result, but now our code is more readable, our code is shorter. So this is how you can use ChatGPT to improve your any kind of code. Doesn't matter whether it is very hard, very big, or at all. That's all. Thank you.